gonna go live here right now. 1 second. Okay, we are live, Bob. Thank you very much for joining me here today on Hard Truths #2. So this is Hard Truths #2 here. He is one of the editors and scientists who has looked at MH370 videos, and I want to give him a platform to talk about his research, his science. Further ado, Bob, I want to go ahead and introduce yourself, your background, tell us why you got good in your research.
Well, thank you very much, Ashton, for your work and for inviting me to your podcast. I feel very honored to follow Salvatore Pai and being the second person on your podcast. For those that are listening on the MFMP YouTube stream, it's going to be a bit broken, but I will upload the full stream that Ashton is recording. So full credit for the work that you've done in this trying to nail down what happened in MH370. It was a bit of a mystery to me when I first saw it, and full credit with bringing together an open research project as such that you've done. It's something that I've been familiar with and been working on in the last 11 years, and so it's great to see this kind of thing emerging in different areas to solve intractable problems. And I think one of the most intractable mysteries of the last, I would say, 100 years is, where did MH370 go? Yeah. So where did I start? Well, essentially, I've always been interested in energy. I bought into the global warming narrative from a very early age. I only used recycled furniture in my bedroom. I built a mirror tile solar concentrator onto the single 12 by 12 inch solar collector that I could afford at the time, way back when I was young. And I charged a lead acid battery up and ran a fan and a light in my room off it. I built, my parents had a motel, and I built a solar heating system for the swimming pool there. So it wasn't all doom and gloom in my early years, but I was doing what I could.
Yeah.
And I've always been fascinated in science. Go on.
I was just going to, have you been an engineer your whole life then? Which is that what you came at?
Yes, in a way, yes. I was very lucky that I grew up with a father whose bloodline had a history of metalworking, being blacksmiths. And we had a farm, actually, which was also my grandfather's farm. And so I grew up with machines, and also we had family anvils, and we had a welding plant, and we had angle grinders and all kinds of tools around the place, and were given a fairly free rein to do all kinds of ridiculous things with metals and explosives and things like that. So I had let's put it this way, with the three brothers, I had a rich childhood and experienced things that not everyone has the fortune to experience. And so when it came to 1989, I was born in 1972, so and right in 1989, I was very, very passionate about science, and I was reading New Scientist journals back to back, even the job adverts, which was a bit weird, I know, but anyway. And so I had like a great interest when I saw this Czech-born scientist who actually came to live in my hometown and went to a school just 15 minutes walk from the house that I was born into, and went to my father's school, called Martin Fleischmann, and he worked at Southampton University, and he went off and worked with this guy called Stanley Pons in the US, and they wanted to look at sort of these deuterium palladium sort of experiments, and look to see if in a metal lattice deuterium could be put into a position where it would actually cause some kind of nuclear reaction. And so there was this work by Paneth and Peters and Wendt and different people that had explored these things. And in fact, the palladium was actually determined before the electron and even the deuteron was determined to be the material that actually absorbed the most hydrogen isotope in I think 1876 by Thomas Graham FRS. I might have got the date wrong, but that's the guy. So it'd been known for 100 years that palladium was the metal that could absorb the most hydrogen isotope, and that there had been some claims in the 20s and 30s and stuff of some kind of transmutation occurring. So they explored this, and they put their own money in for a number of years, and I think it was around about 5 years, and they were kind of forced into this position by a guy called Stephen E. Jones, who was brought in to kind of verify what they were seeming to find by the Department of Energy, whether they were actually seeing what they were claiming, which was he kind of gave the name to it called cold fusion, although Martin Fleischmann and Stanley Pons really didn't like the idea of that phrase being used. They were very uncomfortable with it because they didn't really know what it was at the time. But anyway, they were forced into a situation where they kind of did an early press release, and then they were kind of writing the paper on the back end, and then various people were brought in by George Bush Sr. to kind of give a 6-month crash. Can we replicate this? And it's a very famous story at MIT. They doctored their data to remove their own findings to try and paint the fact that cold fusion is dead. And in fact, there's a person in the community called Ruby Carrot, and she worked with this guy called Matt Howarth, and they produced this book called Discover Cold Fusion. It's a little comic book, actually. So this is something which you can get to understand the little story in here. It's got all the main characters in there. It's been curated by the kind of community around this. But there's one thing which I think people may not be aware about this story. They might have been aware of the people that called it the scientific fiasco of the century. However, they might not be aware about what happened in 1985. And this is called the Pons and Fleischmann singularity, according to me. And in the book, it's got a little diagram here, this little comic here. And what this was, they had a 1 cc chunk of palladium, and they've been loading it, as I understand it, for a couple of weeks, and they had found that it wasn't doing much, so they dialed down the voltage on there, which in my view changes the electrostatic pressure, and they kind of walked away from it. And anyway, they came in after the weekend to find the water tank had all the water had disappeared, the water tank had blown up. It had gone through the glass, through the formica in the wet fume hood cupboard or whatever. It had gone down into the concrete, removed a large chunk of concrete, and in the air there was this fine suspension of particulates. And they realized that this was far beyond nuclear. And this is a story that most people know about, whether they have an opinion about cold fusion, as it was called. I call it coherent metanuclear reactions, and there's a mechanism that drives it, but they're not aware of this event. And I've had the hole variously described as, fairly large to, if you take your fist and you put it in. Now, you imagine concrete. It's got maybe some aggregate in there. It's got some cement in there. What can boil all that water off, damage all that equipment, and then turn a large lump of concrete, having gone through the table, into a very large, there's a very fine suspension of particles that didn't settle over a long period of time? What is going on with that? And so this actually frankly scared them, and they decided that they were going to use much smaller samples from that point onwards. But that was never really discussed in the public domain. And it took a few years before I learned of this story, even when I was working within the community. So what do you think about that?
Yeah, so that's interesting. And quick recap, because I think I forgot to press live stream there. So for the people who are watching, Bob was just going over some history and the reason why he got involved in science and engineering, going through his background as he grew up. Always been interested in engineering. Helping out at his farm, family, etc., and talking about cold fusion, which I thought was very amazing. You were just describing there. What I'd really like to explain for our audience, for the layman, in terms of what is cold fusion and why is it important for us to understand that. Right? Because my audience is people who they really want it in simple purposes. So if you really were to dumb it down for us,
so I'll dumb it down to the simplest experiment that has cold and what appears to be fusion going on. The second person to come out with anything along the lines of cold fusion was a guy called Francesco Piantelli, and I had the pleasure of visiting him in January 2015 in his lab in Siena. And he was in 1989, in August of 1989, conducting a biology experiment. And in that experiment, he had a nickel rod on which he had a mouse brain cell that was alive, and it was being kept alive by being in an oxygen-rich environment and having a stimulation from an electric probe above. Okay. Now the idea of this was to flush that chamber with hydrogen, start the death of the cell, and then freeze the chemistry a certain amount of time after the cell had started to die, and then analyze the chemistry of the cell. And the idea was to try and find chemicals that would allow you, in cases of strokes or when you're going up the top of a mountain and you've got low oxygen levels, to prevent brain damage in these scenarios. So he was a biologist, right? The Professor Francesco Piantelli. And what happened was he'd been doing several cycles of these experiments, and this liquid helium. Now, liquid helium is 4 Kelvin. It's like pretty much the coldest stuff you can get without doing laser cooling and the sort of stuff that's used and has been used to create the first coherent condensates of, say, sodium-23 atoms or cesium-133 atoms. And what he did was, this particular time, after a number of cycles, he put in the cooling, and what happened was it started to boil. It was boiling this 250 watts of cryogenic cooling continuously. There's no power being provided. What is going on? Okay, so he knew he had nickel, and he knew he had hydrogen before, and electricity going on before this occurred, and he ended up by effectively discovering in a biology experiment the nickel hydrogen cold fusion system. And in this context, you can understand that it was cold, and that something was creating heat that was boiling the very cold thing into a boiled state. So this is the best thing I can say as an experiment actually did fusion, but in the cold state. It's obviously not at tens of millions of degrees in a hot plasma bashing particles together. This is something that is in the domain of producing coherent matter, and it is in the domain of having hydrogen isotope in there with a catalytic metal known as nickel. Now, for most of my understanding of this science, until about 2020 actually, I believed, as probably most of your listeners will do, that coherent matter could only occur at near absolute zero. Now, why? Well, the thing is that, and so basically it was predicted, for instance, the Bose-Einstein condensate was predicted a very long time ago by these two characters, Bose and Einstein. And I think it was 1996 or 1997 that they actually first created one of this material in the West. And what they did is they cooled it down to near absolute zero. And at this temperature, let's say you're using, for instance, sodium-23. It's a single isotope, which means if you describe the matter as a wave, you can describe it as a wave. It only has one type of wave, but the wave changes its frequency based on its thermal energy, its kinetic energy, okay? And this is called the de Broglie wave, right? Okay, and so what you want to do is, by cooling it down to near absolute zero, you are getting the same wave, and you are getting it into the same wavelength, but it's still out of phase. And that's where you have a substrate. And the substrate is like, if you have a load of metronomes on a table, after a while they end up in sync, yes? Okay? And this is like, you have a substrate, and that's like your spring, and all your atoms are sitting on there. They're all at the same temperature. They're all got the same wavelength, but then they come into phase. And then you have the same wave, same wavelength, and the same phase, and they become coherent. And they start losing their identity as individual atoms, and they become a coherent matter wave. Now, what I didn't realize is that this can actually happen at any temperature. So there is a patent awarded to Lockheed Martin. You might know them. They are a major manufacturer of peacekeeping equipment, one might say. And
Let's stop that. I'll get married.
And so basically what they did, they had a patent, I think it was 2013, I think it was published in 2017, and it is the first thing I discussed on my blog, on which is at remoteview.icu. And so what this is a they are producing coherent matter, but they note that all you need is the same matter at the same temperature and in phase. Now, the same matter can even be an electron, except you have to create a Cooper pair first by having 2 electrons. Okay? Then you needed the same energy and in phase. And to do that, they use something called the Aharonov-Bohm effect. Okay? And then they use microcavities. And the combination of these aspects leads to the production of a coherent matter wave of any kind of matter at any temperature. So,
Really?
Yes. So this dispels the myth that you need to be at absolute zero. This means you can have fusion occurring at different temperatures. You just need to have them, the same matter in the same phase, able to form a condensate. So if you are a fermion, you need to get it into a bosonic state, and in the case of an electron, you need to get 2 electrons 180 degrees. Basically, they got up and down spin, and you end up with them forming a boson, and then the boson can occupy the same space-time over and over and over again. Now, the Aharonov-Bohm effect is best explained by the Penrose staircase. And so essentially, when you are going, this is kind of like that Escher staircase, where if you go round and you look like you're going down, you're actually not, you're staying in the same point. And if you're going up, you're going round and you're staying in the same point. And these are called a phase singularity. And the phase singularity is able to get matter to, and particularly if you've got electrons, to be in phase. And so what do I mean by in phase? Well, does anyone know what a laser is? Yeah? What is a laser? A laser is something like the same photon, i.e. the same photon energy, so it has the same photon wavelength, but then it's in phase. And so it's the same thing. You're thinking of it as the same thing. And this comes down to what really is matter. And so, what is matter? What would you say matter is, Ashton?
Yeah, it's energy, but in different form, or E equals mc squared. So that's what I would say, is that matter is energy. How close am I? Correct me if I'm wrong.
They're pretty close. They are interchangeable, and you can't get energy out of nothing. It has to come from something. So the way I like to, a lot of people say that energy and light are energy and matter are kind of interchangeable, but it's not so easy to get from one to the other. So often people will say that matter is just trapped light. Well, I'm going to give you an example of what matter is, and that is trapped light. If you take an electron and you take a positron, which is the antimatter of the electron, okay, and you fire them at each other, they will annihilate. And what you get produced is 2 photons at 511 keV going at 180 degrees from each other. Now, what is significant about 2 511 keV photons? I'll tell you. That is the mass of an electron and a positron. So there's a conversion of the matter, the electron, into a electromagnetic wave. And so you can actually do matter synthesis by taking a gamma wave, firing it into ordinary matter, and it can produce an electron and positron pair. So you can do matter synthesis and you can do matter desynthesis. Okay, the electron's probably the easiest example, and this is, it's actually used in practical technology like positron emission tomography. Well, actually, it's because the decay. You get positron coming out, that produces an annihilation event, and you can see these photons coming out. Okay, so there's real technology. So essentially, cold fusion is coherent matter nuclear reactions. You're getting matter into a state where they can occupy the same space-time, and the structure that does that, in my view, I will talk about as we move through. But this is the thing that effectively was created by Pons and Fleischmann when they had that singularity. And what they created, in my view, was ball lightning. Ball lightning and microball lightning and itty-bitty-bitty microball lightning and extremely small ball lightning and very big ball lightning, they're all quantizations of a stable plasma structure, which has at its core a toroidal vortex structure.
So let me just ask you, I'm going to recap real quick, because someone was breaking up. I just want to make sure my audience can hear what we were discussing, because I thought that was pretty amazing. Pretty much describing what cold fusion is, how it comes about. I think some of the points that I heard there, and I wonder anything that I might have missed, is matter is essentially trapped a lot. Cold fusion can happen at temperature, which was Einstein condensate. It can be different temperatures as well. I'm not sure if that's accurate, but that matter can convert to an electromagnetic. And the idea behind going from fermion to a boson, which has different points in space-time, compared to boson, which is like a laser beam, where we can fix that as a matter of aligning the wave so that the waves cohere with one another. That can cause coherent matter reaction. Is that pretty accurate, or did I miss anything important in there?
Yeah, I mean, essentially,
that's pretty awesome.
You can actually create coherent energy from all kinds of things. So there are these active denial systems that use what's called SASER, which is effectively the equivalent of a laser, but using sound. And they are terrible. They are disgusting weapons, actually. They're not just active denial, because when the coherent sound comes into your skin, it goes into your piezoelectric bone or your piezoelectric tendons or your piezoelectric teeth, and you get what's called phase conjugation. The sound comes back and you get the same stuff we produce in ultrasonic experiments that does cold fusion in your body. So it actually mashes up your body. It's disgusting that is even allowed to be permitted. It should be banned. In the case of laser, people understand laser, but there's a thing called maser. And a maser is a microwave laser. And there's also called baser, which is essentially a coherent matter wave, right? Beam. So a baser is a boson, a Bose condensate laser, okay? So there's these different things about dealing with coherent matter. And if you look at what is in the Lockheed Martin patent, and I will pull it up here probably. That's probably a good thing to pull up so people can understand that this is a real thing. And it's sadly, I mean, well, I'll come to that in a minute. So essentially, we launched this.
Yeah, no problem.
Yeah, we launched this project. What it was it all went quiet. There was an effective disinformation campaign around this technology. I don't know the truth in this, but there is a story out there that Stanley Pons had a gun put to his head when he opened the door, and it scared him so much that he literally fled the US. I think he relinquished. He was half French, half American. He gave up his American passport, and he went to France, and he was funded by Toyota, and they worked together for about 5 years, funded by Toyota down in France. And essentially, no one has seen Stanley Pons. He's still alive. Unfortunately, Martin Fleischmann died in the year that I tried to go to the first conference in this field in 2012. But he did write the foreword to a book called Fusion in All Its Forms by Jean-Paul Beberian, who's a leader in the condensed matter nuclear science field. So, and I understand at the time that they both fled, and they dumped their equipment with whoever they could to get out of the country. I mean, it was a really frightening scenario for them. And I don't know how many people knew about the event that I talked about, this singularity, where they saw something, well, in their opinion, beyond nuclear, a coherent matter, ball lightning-like effect, in my view. And so there was a campaign to shut them down, and I didn't get interested in this until there was a very flamboyant guy called Andrea Rossi who went public claiming all kinds of things, and he tried to actually reach out to Piantelli originally to get his engagement, and Piantelli refused. And then he went to a nuclear scientist at Bologna University called Sergio Focardi, and he stepped in and kind of gave credibility to what Rossi was doing. Whatever, whether Rossi had something, has something, or never had anything, it's completely irrelevant. What he did was he did showmanship. And the showmanship got me and at least 4 other people to go to the conference in South Korea at the KAIST Material Institute of South Korea. And when we were there, we were looking at all of these scientists who were seeing the same kind of products being synthesized in solid phase fusion systems, in liquid phase, and in plasma phase, gas phase, whatever. They were seeing it across all these different systems. But they had at least 70 theories. And they're all trying to win the new Nobel Prize. And like, if you've got 70 theories, well, at least 69 of them are wrong, right? So when you ask what is cold fusion, it's not quite so trivial. And so, but what was interesting is that if anyone was having a reasonable amount of success, either a pseudo private entity or a private entity maybe, or a government body would swoop in, they would invest, and they'd get them spinning plates until they died. And dying they were. And we realized as a collective, the so-called young people, we weren't that young, but younger than a lot of them, in the room, we realized that if someone doesn't do something radically different, then these people are going to die with all of this incredible wealth of knowledge. So we came together, it was 4 of us, and formed the Martin Fleischmann Memorial Project, which you can see at quantumheat.org. This was the original website. It's mostly an archive site, although there is a current project up on there right now called Thor. And essentially, the idea is I wanted to create a system where we could publish experiments live on the internet, unredacted data, and that people could guide and inform on the design of the experiment, the protocol, what equipment was being used, how the analysis should be conducted, and so on. And then they would have the live data actually published as the experiment's being conducted. And they can actually comment and suggest how the experiment should change. And we were doing this with equipment that a guy called Ryan Hunt, one of the founders, actually made his father made it, and it was like for monitoring home energy systems, and they repurposed it so we can actually show these live data. And this was before any of the major digital acquisition companies could actually do this kind of thing. And we needed then one person at least to provide us with an experiment. Okay, and one person did come forward. And that person was a guy called Francesco Celani, and he worked for the Italian Nuclear Frascati Institute, and he had a piece of constantan wire that's nickel and copper, and it was loaded with hydrogen, and he would heat it up, and he would see excess heat, and he had shown an amount of excess heat to the tune of in excess of 20% at National Instruments Week in Texas and in the conference, and it was a live demonstration. So we set about raising some money, and it was all funded by small donations from the public and from our own personal resources as people setting up this open project. And that early work was largely funded by Ryan Hunt's father, Paul Hunt. So thank you to him. And thank you to all of the people that helped this work. And essentially, the claimant, they next wanted to do fusion by increase their excess heat by raising the temperature, and they had a thing called borosilicate glass. And they next wanted to use fused quartz. Now, the borosilicate glass softens about 300 degrees C. Fused quartz can go up to like 1,700 degrees C. So we thought, well, he wants to do that next, so let's do that now. And so we did it, and we didn't see any excess heat. So we thought, we've done the first thing wrong. The first thing is, don't try and change the experiment. We changed the experiment. I know the experimentalist was going to do it, but we changed the experiment. So we went to borosilicate glass, and we attempted a second time. This was with Mathieu Villat, another director of the project, and we started the experiment on 12 seconds past 12 minutes past 12 on the 12th of the 12th of the 12th California time. Of course, it was started in France, but anyway, we thought that's not going to happen again. And 2 days later, I was in a military base in Rome, publicly giving the data. We had achieved 12.5%. It would have been better if it was 12%, but it was 12.5%. And then I gave my presentation. The experiment was still running. They could analyze the data live at the back of this military base presentation room. And after I gave my presentation, I walked out of the room, and I was probably about 8 meters from the room, and I heard this fairly sturdy, brisk footsteps running up behind me. And on my left shoulder, this Italian general tapped me, and he said to me, and he kind of whispered in my ear, he says, "You need to use an alkaline metal." And I said, "Well, what do you mean, like lithium?" And he said, and he just smiled and walked off. And it was much later that we found out that they did use deuterium, but when you take pure water like you get from a scientific grade from a supplier, chemical supplier, and you take the heavy water, so that is not H2O, it's D2O, okay? You need to make an electrolyte so you can do the electrolysis. And it turns out, and we were actually through Jean-Paul Barbarian, Pons showed and handed over some of their stock of their electrolyte, which was lithium aluminium deuteride. So they had lithium in their experiments. Okay?
So lithium in the secret then? Is that the secret sauce? So
well, I'll tell you.
Lithium is one of these things we can turn into a boson-Einstein concept. Go ahead.
So have you heard of Castle Bravo?
I have not. I'm pretty new to all this. I'm my best to catch up on this science.
So Castle Bravo, I think it was the largest atmospheric test or the largest nuclear test in, I think, the Polynesian Islands. I don't know, like out in an atoll out in the Pacific. Okay, and it yielded 2.5 times their expected yield. Now, what normally happens is you get neutrons, they go into lithium-6, and that forms 2 tritons, two heavy hydrogens, and they go and do more fusion, okay? Because one of the easiest reactions is a deuterium and a tritium in a thermonuclear bomb, okay? So, in fact, if you look at fusion reactors, they will have a lithium jacket, and the lithium jacket is where the neutrons are caught by the... And what it has is the lithium itself has a high cross-section. What that means is it's good at stopping neutrons. So 1, you stop the neutrons, and 2, you convert that into more tritium, right? And so what they didn't expect is the lithium-7 actually playing a role. Okay, and now lithium-7 is most of lithium. So if you don't purify your lithium, I think it's like it's only like 10% or at most, I think it's something like that, is lithium-6 off the top of my head. You can go and look it up. All these things, I'll say some slightly vague things, and they're all things you can look up in Wikipedia, and it's like, go and do your homework. It's like, I could do it now, but it will stop my flow. So the basic thing is, the basic thing is that it was lithium-7 that's responsible. Now, I have given in presentations that in recent years, that the nuclear research groups in Russia have found that okay, this is a bit of a jump in the logic here, but these clusters are made from a weird stuff. It's complicated to go into it, but essentially it's Tesla's etheric matter streams. And there's a guy called Kuroz and Shishkin and another one called Dubovik, Vladimirovich Dubovik, and he is a total savant. There's an electric field, and there's a magnetic field, an electric dipole, and a magnetic dipole, and these are all things that are well understood in the West. He discovered, as part of his thesis, working at Dubna, the nuclear research center north of Moscow, in 1965 and published in 1967, something called the toroidal moment. And this thing, which I will show some imagery in a little while, this allows you to create structures that have what's called a non-radiating boundary, and ultimately I believe that they are the thing that causes ball lightning. Anyway, what they found is that there is a structure. Go on.
Yeah, well, you mentioned ball lightning. First question I have on the quick is ball something that can naturally occur, something that we have to produce? Then with the non-radiating degree, is that the shell of the ball lightning? How would you define that?
So I can show you papers from 1992 from Edwards Air Force Base, which are declassified. I can show you them on this stream, where they show this non-radiating boundary and that they have quantized their levels, which means when you know this science, you know that there will be scales at which this can operate. Okay? And you will know which subfractal scale you will need to generate the fractal scale above. And the skin is, it would appear, superconducting and superfluid. And we can show in our experiments where we've had exactly that kind of interaction with other material, and when it gets into this state, it can cut through anything. It's like literally like a Star Trek shield, like totally like a Star Trek shield. If you built this and someone was firing something from the outside, it would eat the thing, whatever speed it's traveling at, one atom at a time. It would just become part of the Borg on the outside. But we've done it the other way around, where a guy called Henk Uren has created these things in his experiment, and it only cuts on this boundary layer when it gets up to this threshold, and it will cut tungsten like that immediately, but it does nothing until it gets to a particular point. And then there is another one where we've got this copper tube here, and I've got it right here in front of me, this one here, which you can see, and this was a copper tube sat on with a piece of iron above like this one and another one below. So thank you, Henk Uren. He operates out of Holland, and a ball lightning formed, and it produces a hemisphere in this case, and it cut instantaneously a hemispherical section out of this copper pipe. And it's like a flash. You see it on the camera, and you see the little flash. Now, there's several things I can offer alternative hypothesis for which you've tried to explain in some of your discussions. Okay, but I need to just round out the angle I was on previously, which is,
sure, go ahead.
If you are able to get a copy of this out-of-print book, The Secrets of Cold War Technology, Project HARP and Beyond, by Jerry Vassilatos, he talks about how Nikola Tesla, when he was doing his unidirectional disruptive discharges, he would at a distance feel these pinpricks in his body. And these are similar to those observed by people who have been close to natural ball lightning. He would go back 15 feet from his device and he would still get these pinpricks. He would then erect a glass sheet. He would still get the pinpricks. He would then erect a copper sheet and still get the pinpricks. He only found that he didn't get the pinpricks if he was using magnesium, beryllium, or aluminium. Anything heavier, and he would start to get these pinpricks. And he called these pinpricks the result of dirty etheric matter streams. Okay? These are toroidal clusters of something that's inside matter. Okay? They call it the hidden energy within matter in Russia. And there was a declassified 1992 document on the CIA's website. It was declassified in 2017, called something like, oh God, I can't remember offhand, Journey to Alpha Centauri or something like that. And it was about extracting enough energy from 1 kilo of iron with a technology that would also provide the propulsion technology to get to Alpha Centauri in 6 years from the energy that is extracted from 1 kilo of iron. And the energy extraction technology is the propulsion. And, by the way, in the same document, bearing in mind this is 1992, they say that this is the same technology as cold fusion. They literally say it is the same technology, right? So, what Karols, Dubovik, and Shishkin have established is that for hydrogen isotopes, it's 2,000 to 4,000 times easier to create this etheric matter that Tesla observed than for any other element beyond lithium, which implies you can create the etheric matter from lithium. It is a similar level of ease.
Wow.
So this is far more interesting than just creating coherent matter from an alkaline metal. This is creating something that is subatomic, and they believe it's a cluster of what's called background neutrinos. Background neutrinos comprise of more than like 2.5 times the mass of all of the visible plasma planets. Like if you take our solar system, 99.8% of the mass of our solar system is the sun, right? The rest of it is just flecks of dust running around that. Yeah. So, and we're a small speck of dust, right? We might think we're big and important, but we're not, right? And you compare our sun to Betelgeuse, and it's like it's not even registering on the radar. It's a speck of dust around Betelgeuse. So, and you add up all of the suns in all of the galaxies in all of the universe. And there's still 2.5 times more of this stuff. And do you know what? It's all at 2.76 Kelvin. It's all the same stuff with the same wavelength at exactly the same temperature. It's a coherent matter condensate through the entire universe. It's one wave function everywhere, all at the same time. And this is what the toroidal moment can capture, because it also has the ability. So it's a relic neutrinos. They are able to interact with two things: the weak force and gravity. The weak force and gravity. And these things can suck through. So I can take you through a few slides. I can take you through a few presentations. But I believe that in a simple segment in this, using only the words of John Archibald Wheeler, the inventor, often credited to, of the term black hole and of wormhole, I can use just a clip from him with what I've already told you to explain what you see in that video. Now the question is, why did I get interested in that video? Well, in January 2021, I was asked to be interviewed by Ross Coulthard as part of his work to try and work out what was going on between these various so-called disclosures that were going on. And I described to him, as probably the second or third person in my life that I've ever described to, something that occurred to me and my siblings in 1979. I was standing, I was just in the house, and my dad called us all down into our lounge, and this was at 32 Offington Gardens, Worthing, West Sussex, UK. You can go and look at it on Google Maps, right? 32 Offington Gardens, Worthing, West Sussex, UK. And out of the back of our lounge, there's a glass, like, you know, big French doors. And he just told us to look up into the sky. It was a late summer evening in I think it's 1979. I think I was about 7 years old. I might be wrong, you know, memory plays tricks with you sometimes. But anyway, that's where I think it is. And what happened was 4 lights went zip, 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 and then he said, right, kids, you can go to bed. And I was like, what the fuck? I don't even know what I'm seeing there. And I didn't think of anything other than, like, Dad showing us something in the sky. That's nice, Dad, thanks, goodbye. And I didn't think about it until one of the sponsors of our project, a guy from Sweden, kept telling me to go and see the Serious Disclosure project. And I thought, okay, all right, God, he's into UFOs, so that's fine. All right. Finally, I relented after a couple of years of him trying to get me to look at these things. And I looked at it, I go, all right, that makes sense. All right, well, maybe that's what my dad was showing me. And so I met him in Prague, and I told, that was the first person I told. Like, and I think it was maybe one other person, and then then it was Ross Coulthard. And so when you started, what it was Mathieu Vallat, who conducted that first successful experiment on the Francesco Celani cold fusion nickel copper system. He contacted me a number of weeks ago and said, "Have you seen this?" And I looked at it and I go, "Oh, I know what that is." and I've only recently, like in the last couple of months, realized that due east in the line that we were looking is Shoreham Airfield, which is the oldest custom-built airport in the world that's still running. Okay, there was an airstrip that was laid for the Wright brothers to land, but this is the oldest one. And so my father had good contacts within the UK Navy. I know this for various reasons, and because of what he did in the Navy. And he was also a very senior Mason and very well respected, and so was his father above him. And so I don't know whether it was put on because of his Navy contacts, or was it because of his association with the Masons. But this was 1979, right? And they looked exactly like those spheres that are running around that plane. Wow. So I don't think this is a new technology. And I can show you documents that will show or imply very strongly that this is not new technology. And I can show you them in a minute if you want to see them.
So it's been around for... Quick question on that before we dig into that. Mm-hmm. How did that... You just told exciting that you had, right? Did that change you, or how did that do when you saw that, and did it change, you approach science? Did it make you interested in it? I'm just curious as your thoughts.
I had literally no thoughts about it at all. You know what? I didn't think about it at all until after I saw the Serious Disclosure. Because I thought, well, hold on a minute. Because the point was I looked at the Hessdalen lights. And the Hessdalen lights were... there are phenomena in this valley in Hessdalen in Norway, and there's a couple of metals. There's a lot of metals that are mined in that place, and it's got quartz, and it goes through these large temperature changes, and there is this sulfurous stream that runs through the center. So you've got basically a big freaking battery there with a lot of piezoelectricity, and some people have claimed these things are they're certainly unidentified aerial phenomenon, or UFOs, as we might have called them back in the day. But they are free-floating plasmoids of some type, or ball lightning. They're essentially ball lightning. And so I walk through how what we have observed and can repeat at will in experiments are the same things. They're just bigger, right? They're just a bigger quantization of this. And there's a bigger one beyond that called Earth lights and stuff. And so there's a lot of the community. So I was already around the periphery of ball lightning, and I literally had not thought about it. And then I saw the Serious Disclosure. And I thought, well, I better start talking, because I could realize that a lot of these things were natural phenomenon, and you could man-make them. And I'd already seen them. And I know my dad's not a freaking alien, right? He's not an alien. So like, it can only be a thing that we're making. And since I've deduced that it was from an air base, then maybe it was an early version of this as a defense system, you know, or maybe it was just showing, oh, look, we can make these pretty plasma balls and we can control them. And the idea that you're moving around and you're changing direction very fast, that's because they're not a physical object and there's no one inside them. You're literally, if you know how you can get a laser pointer and you can move it around really quickly in the sky. Well, imagine you've got some phase conjugation and you've got some interferometry between electromagnetic waves, and where they cross, you've got a cross point, and the thing is stuck on that node. You could move that around as fast as you can move those beams around. These things would be relatively easy to control. It's like chasing a laser pointer with a cat running around. So
question on that, on moving around. So, and this kind of digs into the videos a little, but what I wanted to refer first thing is, how do you think you would control that? My approach would be that would be a remote control function that you would use, but do you get on that?
So firstly, the movements that you see in that video, they are relatively trivial in mid to early 1990s animation software. I was the first trainer of official registered new tech lightwave trainer in the UK in the 1990s, right? Along with my business partner at the time. And with the software then, you can create those moments easily, right? The second thing is, why 3? Why 3? Well, 2 is geometry. If you have 2 like this, you can't make a plane from 2. I mean a plane, not as in a plane flying, get on it and go to another place. I mean a plane as in a piece of paper. You only define a line. If you have 3 like that, you can define a plane. And that means you know what the normal of the plane is, right? And you need this technology to have the central azimuth going through the central 90 degrees perpendicular to the plane. So it needs to come out there. The plane needs to be in the perpendicular to the plane that's created by the 3 points. And you'll see when it comes to its final position, before it pinches in and they rotate around to join their gravitational waves together, and I'll explain this with Wheeler's words, and it will be very simple, that you see them, now you show a picture of a charged rod with water droplets moving around it with static electricity in zero gravity. I saw on your thing. Okay, so that's what happens, right? Whatever. Whether that's happening because it's happening, it doesn't matter. They need to get those things equidistant between each other, and to a degree they will self-organize because they repel each other as well as attract each other. Okay. Then they need to be aligned in the same azimuth, and then I will explain using Wheeler's work in a little while once we've gone over some principal context. Now, the moving them around, you synthesize them largely using the Lockheed Martin pattern. You need to create a lot of coherent matter, and when you put it into a ball, in their pattern, and I think it's in drawing 3, they show a buckyball-like structure of a coherent matter structure. It literally is a buckyball. And this is the structure that we see in our experiments. It makes these kind of like carbon nanotube type, buckyball type impressions and an arrangement of the matter around it in the brass samples that we produce, right? And so I've been saying for years, like it forms these tubes and these spheres and stuff, which have a 5-sided and 6-sided sections within them and branches coming off, and they are effectively, because they're a superfluid of electrons, they at least that's how you initiate them. They can form this particular structure on the outside. And then you move them around by effectively toroidal moments and interferometry, which is interacting electromagnetic waves probably with what's called phase conjugation, which is where you have a wave and another wave 180 degrees out of phase, and that produces nodes which are effectively scalar. And this is clearly discussed by Tom Bearden in his 1980s and 1990s work and stuff. In, for instance, this is Third Lance, one of his later books. Okay, so most of the stuff is in the literature that you need to understand. So if I bring up the paper from Lockheed Martin, let me go to my blog. So you can go to my blog at remoteview.icu, and you can type in, probably in the question, you can go coherent, and
you'll share that in your chat.
Well, yeah. So like I can just pull it up here for those that don't know what.
Oh yeah, sure.
So
real quick, while you're doing that,
yeah, go on.
I wanted to ask: is the azimuth the kind of the surround, the sphere that they create with the three?
Okay.
How would you describe
it? I'll do it in 3D. So give me a second. I'll share my screen.
Yeah, thank you.
So I'm going to have to drag you down here. Sorry, guys. So, and I'm going to share my other screen.
And share permission.
Okay, share screen here. Okay. So can you see that? No, you can't see that yet. Let's do that. Go share. Right. Can you see that?
There we go.
Okay.
Oh yeah. Okay. Now we're cooking. Yeah. Go.
Right. So you can see the central spot of this cone here. Yeah. Which I'm pointing at. Can you see that?
Yep.
Right.
Yep.
That is the point of phase singularity. That is where your electrons will come down this spiral, and because electrons repel each other, they will end up 180 degrees out of phase, and then at this point they've got no space. So they have to become coherent. Anyway, and this is the point that creates the Aharonov-Bohm effect. Okay, and this was talked about by Eric Weinstein and Hal Puthoff in January or February 2022 in a presentation that's available on YouTube, and they talk about this Penrose stair diagram that I also used to describe the Aharonov-Bohm effect, and then and the fact that is the only thing that will allow us to break. It changes epsilon 0, so you can change the light speed and the properties of the physical vacuum to form charge. It changes the dielectric constant of the physical vacuum, and this allows you to change time in here and also change the speed of light, and therefore you can go faster than light with the epsilon 0 changed. And they talk about this, and then Hal Puthoff replies by saying, oh yes, and you can go even further than that. There are all kinds of toroidal geometries that you can blah blah blah, and he then talks about the communication technology. But anyway, so there's this, you see this little ball at the back here, that is the disruption zone, and the flux, the gravitational wave comes through here, all through from this point all the way down here and out through the top. Okay, now I'm going to show you this literally in 3D because I have the light wave here. There we go. So I can actually spin this puppy around here, and you can see our three substructures, which are exactly the same as the key large structure. So this is what you need to produce, and when they get this close, they will create the fractal above. And so each of these cones has a gravitational wave that comes through, and when you are running this ordinarily, and this is the monopole, so it's a topological monopole. So I will show that with a piece of Photoshop here. So this is.
So each of those donuts in there, I recommend would potentially in order. We would be seen visually.
Yes, each one of those will have there will be their own sphere, and then when they join the gravitational waves together, they make a larger one at the quantization level above, and they literally snap to that quantization level. Okay, so here, if I can show you with the layers, this in fact I'm going to bring up the paper so you don't think I'm making it up. This is observation of Dirac monopoles in a synthetic magnetic field, and this is by a bunch of people, M.W. Ray, and this was published in Nature. Okay, so this is what I mean by a synthetic monopole. You end up with a structure here, and they end up looking like hedgehogs, and it's, anyway, you can read the paper. But here's their paper showing, and I'm going to show this diagram with the model that we derived. And the model we derived was from experiment only. No maths, no preconceptions, whatever. We just looked at what nature was doing under a microscope, and I kept drawing pictures that would fit until it fitted everything. and it ended up being this thing that is just a thing of great beauty. So what we have here on this right-hand side is a comparison between experiment, which is everything that looks beautiful and clear, and fuzzy rather, and simulation, which is everything that looks really clear. And it says experimental and simulated condensate particles. So these are Bose-Einstein condensates, densities with a monopole near the center of the condensate. Comparisons along the vertical axis are shown in rows A and B. A and B. I think it's a row. A and B. This is along the vertical axis. And those along the horizontal axis are shown in rows C and D. Okay, I mean, it depends what your perspective is, but anyway. So this is essentially what these produce. And if I show you here, and is it here? Not there. Not there. I'll get there in a minute. Here, okay. So this is what I showed. This is from Aalto University. It's the same thing. So you have your spin horizontal, spin down, and spin up, okay? And this is the bit that glows inside that sphere, right? When you've got the spin change. And coming into the bottom, you have this monopole point here. It's a topological monopole. It's not a real monopole, but it acts like a real monopole to a degree. And you can, the Russians have done lots of experiments where they show these things creating these little birdie structures on X-rays when they're generated. Yeah. And you can generate them, by the way, by taking a cone and spinning the cone very fast. And these monopoles are produced, by the way. And if you get if you get 4 cones and point them to the center, you end up them aggregating in the center, and then it looks like a particular pattern by Salvatore Pais, doesn't it? Okay. Anyway, so here I can overlay this O structure here, and you'll see this is from the side, and this is from the top. And if I turn on the geometry there, that is what's going on. And it even has the cone bit coming in. So this is what you see in those various images, in my view, in my hypothesis. Okay. Yeah. Now, the interesting thing is, this is their mathematical prediction, but this is what the Bose-Einstein condensate looks like. And can you see the S? Yeah. And the S is there.
There's a little S in there.
The S is there because it's actually got the subfractal. That produces the S.
That's interesting.
It's a wheel within a wheel within a wheel.
It is very interesting. So is the monopole facing the opposite direction of where the heat signature is with that, I would almost call it that half circle shape that we see that you were showing a second ago? The monopole
this bit here.
Yeah, that one there.
Yeah.
So where's the monopole there? The monopole's facing
the monopole is, yeah, so if you look, I've got this mapped across. So this is the spin up, spin middle, spin down. This is above the overall structures. You can see there. Okay, so this is the non-radiating boundary. Yeah. This is the oval sphere that you see. And it fires a gravitational beam through the center. Okay. What happens with charged particles, they come in and they stop at the phase singularity here. Okay? And that, you don't need to power these things once you've made them. They self-power themselves. They are what's called an anapole. They don't radiate their energy. You can put more energy into them. They're quite stable. Right? So they can last for days.
So how would you, so in terms of going into the videos, what we've seen in the videos with these orbs moving around, how would you define the direction of travel while looking at your 3D, your model here? How would you determine the direction of travel exactly? Where and what would you expect it to be based on what we're looking at from this visualization? So
okay, let me do that. There is what I've got here.
If you have the videos, you can pull them up your side too.
Oh well, I think that
your it on my side,
your viewers have seen them, and I know what you're talking about. So, essentially, these structures have a beam that comes out. It comes out the back further. Okay. How am I going to do this? I'm going to have to change my layers here so you can see. I've got this three Tor one here, and I can break it down so you can see the substructures here. So I'm going to take away the. That's the main Tor there. Take away the lemon, the apple, and the. Okay, so here. So I've got a 3 sub-Tor structure, and the sub-Tors are only made of 2. Okay. Now, what happens is, where this disruption field interacts with the Tor above, you actually have a leak. And the leak is reduced. So in the alien reproduction vehicle, they have 48, which is the maximum number you can have round. And this is in just ancient stuff, but anyway. Oh dear, oh god. Yeah. So the point is that you have this beam, and I can show it by showing the. I'm going to turn it off, and I'm going to show the normal ones, and they have this disruption beam that comes out. Okay. And it has a certain level of extension.
It's almost perpendicular to the torus.
Yeah, well,
am I mistaken?
you'll see it in a minute. I meant apple outer shell.
Okay.
So you can see here, and I've not. This is only for a 2-Tor structure, but like I say, you can't use two Tor practically. You have to use 3, and 4 is pointless. You don't need any more than 3 to define a plane. Yeah. So the plane actually has to be within this part. So you cannot change where the plane's got to be. The plane's got to be from here. In the center of what this is literally the Vesica Pisces, the fish bladder. It's the sacred geometry. The plane has to sit between this point and this point here. Okay, so the plane has to fit in this zone. All right, and then it can be acted upon.
Okay.
Anything within this overall bubble. Epsilon and mu is changed. It's called the permittivity of the vacuum. Epsilon 0 rather is changed. The permittivity of the vacuum, and so the speed of light and time and electric field properties will change inside this, and it's all detailed in a paper by one Kenneth Radford Shoulders from 2000, and the document is called Permittivity Transitions. Permittivity Transitions. Kenneth Radford Shoulders. Kenneth Radford Shoulders demonstrated and showed that all sparks have a ball lightning, or what he calls a charge cluster, and eventually called an exotic vacuum object, as a leader. That doesn't matter whether it's a spark coming out of your finger or the leader that ionizes the channel from the low potential to the high potential between a cloud to ground, ground to cloud, or cloud to cloud lightning discharge. Okay, it's always got a ball lightning that does a charge cluster that does the ionization channel first, and you can see this on extremely high speed footage of lightning. And these things will get excited, and they will split up and produce your lightning branches, but it's only one that will hit the higher potential. And so so it doesn't matter whether you've got 3 or whatever. So I think what I need to do is just go through a couple of papers which you need to note down, and your followers need to read and get up to speed on.
Yeah, please.
So essentially, this is a topological monopole, and we create them, and we've done a lot of that. So the first one, no, before I do this, I need to show you. I need to show you something else.
Oh, yeah.
Okay, so okay, all right, so not here.
Oh wow, look at this.
Okay, so
okay.
All right, I will do this here, and I will do it as present the view, and then I can see you. Can you see that?
Yep.
Okay, so
I remember I was looking at this, I think, when you did your presentation a few weeks ago.
Okay, so basically this is 23. If you have 24, that's half of a circle, that's 48. That is what I observed by looking at this particular sample by John Hutcherson in 2020 that was synthesized in 2007. Okay, so on here I found several quantization levels on there using a fairly cheap microscope. These things do not care about electric and magnetic fields. This is a high magnetic electric field in Henk Uren's experiment. These are actually the same kind of thing, these little plasma balls. They don't need to be luminous like this to this level. You can see a less luminous one up here, okay? You can see an almost unluminous one here, okay? But these ones are luminous. So you can have ranges of luminosity on the outside. They produce these. This is a coherent matter wave here, and it's two things orbiting around each other. Sometimes we see three, and sometimes we see more. This is effectively the same things as you're seeing, but already in the next quanta up that you're seeing going on with the plane, in my view. So it comes out of Winston Bostick's work. He was charged in 1948 to make a fusion technology that was practical out of the thermonuclear bomb, and he worked on Project Sherwood as part of the Atomic Energy Commission, and he worked at Los Alamos and Princeton University and so forth. And he shot toroids of plasma, okay? And this is deuterated titanium, and he does a discharge 10,000 amps, incredibly small amount of time. It produces a plasma loop which has a current going through it, which reconnects and forms a torus. That gets passed over a magnetic field, and it forms a tori of tori. That is the structure. That's the basic structure. And this is talking about non-radiating boundary. People can look at these peer-reviewed papers in Nature Materials, and you can also download the book Evie, A Tale of Discovery, which is 5 years after Ken Shoulders. So who is Ken Shoulders? Ken Shoulders is the guy that was brought in my view, by the CIA to investigate John Hutcherson's work from 1979. So he came in 1982. 5 years later, he was awarded several patents. Go and look at them. The way that he creates these exotic vacuum objects is the same way that Lockheed Martin claim they create without crediting Ken Shoulders in their 2013 patent, right? Go figure. And it says here, these waves can be thought of as longitudinal waves in the vacuum. They are largely undetectable by standard electromagnetic detecting means, but are readily accessible in the monopole world. This is 1987. There appears to be an incredibly large number of useful phenomena yet to arise from using potential effects that are not immediately accessible to electromagnetic fields. This is vector and scalar potential. What happens with these structures? The most simpler one, this is an anapole. It was discovered in 1954 by Zaeldovich. Okay, you have toroidal currents here, you have a magnetic field going around. These poloidal currents, they oscillate, and you have an electric oscillating field. This is the most simplest one, and the fields cancel at a distance, and you only get the vector and scalar potentials outside. Okay, so these things quantize, and they are self-contained structures. And if you pump energy into here, you can keep pumping energy into here until all forms of matter will decay. Now, you don't need, when you have a fractal toroidal structure, and this is published in a 2017 paper in a major peer-reviewed journal, you do not need these oscillating components. It will self-organize into a non-radiating plasmoid structure. Okay, this is in Nature Materials, and it's basically describing the same thing as was described by Ken Shoulders 30 years previously. So do you think they didn't do anything with Ken Shoulders doing these patents? And, no, I think they did a lot. Here's a third order structure with that. Sorry, what?
All right, keep going. Sorry.
Okay.
No, you can keep going.
Yeah.
After you're kind of done with this part, because it's very interesting. It goes back to what you're showing here, where you matter.
Yeah.
It goes back to the videos if you want to address that. I remember I was watching your presentation a couple weeks ago, and one thing that I thought was interesting, there's two possibilities, is that this is either some type of teleportation or some type of annihilation event. And early on, I was all about thinking there was an annihilation event. But I ruled that out because I thought, well, since E equals F squared, this mass has to go there. Our zap must have been a lot bigger if it was an annihilation event. I'm wondering, can you correct my understanding of that? Or
okay, so yeah, I think you've asked the question, so let's address that now. One, when this matter is condensing, it releases 2 kiloelectron volt photons. They are not thermal photons, right? And so you don't see them in IR, but the energy is dissipated. Secondly, if you get to the point where you get unification of the forces, and so if you go and look at a patent by Mikhail Solin, which was awarded in the USSR, actually not, in the Soviet republics, so it's 1992, for his quantum coherent nuclear reactor. He fires an electron beam into a low vapor pressure metal, and it forms these solitons of opposite magnetic charges that form clusters in spheres or tubes, and inside there you get unification of the forces and decay of baryons. What are baryons? That's a neutron or a proton in a nucleus, and the baryons can decay into light and leptons. What do I mean by that? Light, well, you know what light is, but light doesn't necessarily need to be thermal. It can also be gamma rays, it can be X-rays, it can be extra low frequency rays, none of which you can see in the visual but if you have X-rays coming out, they will excite air molecules around it, and they will produce photons in the visible spectrum, which are still not thermal, right? Okay, so, and then leptons can be either charged or uncharged leptons. A charged lepton is an electron, a muon, or a tauon, or the uncharged leptons is electron neutrino, muon neutrino, or tau neutrino. You can have a vast amount of energy released without any explosion, because it's an implosion event, and then it releases what the Russians call field forms of matter. And I'll give you an example. There's a guy called Mahadevan Srinivasan. He worked at the Babratomic Research Center. About 20 years ago, he was given data from a electric arc furnace in India, and they had 3 something like meter wide graphite electrodes, something like 11 megawatts going in. So you got 3. Interesting, it's 3. Anyway, there's 3 of these going into what's called a ferrosilicon furnace, and what they were chucking into this was scrap iron, sand, and coke, like charcoal. And what they got out of it was iron silicon alloy, ferrosilicon alloy. What they found was, it's a continuous process. You can't stop this, because once you stop it, everything's set solid, right? So you have to keep it going. For 11 weeks, they produced 3 tons of excess silicon and 1 ton of excess iron per day. Right, for 11 weeks. And if you work that out, it's something like 350 tons, which is the mean weight of an A300 or an A300 ER, whatever it is, the bigger one, right? And you know what? There isn't a massive hole in the middle of India. And if you take, where's the silicon coming from? Well, if you take carbon and oxygen and you fuse them, you end up with silicon. 12, 16, 28, right? So they were doing fusion using intense electric energy, which will, whether you like it or not, it will create these vortical flows. If you've got 3 electrodes in there, it's going to do some stuff. Like this one's going to spin around here because you've got an electric arc, and then you've got a magnetic field spinning around. There's going to be spinning here, and spinning here. It's going to be creating these same things because you've got hydrodynamic shear. When I say that, it's in the fluid of the metals, which all got in a plasma kind of state because the electrons are not associated with any particular nuclei. You're going to get these structures forming. So it's unsurprising. So you don't have necessarily a nuclear bomb-like effect. You don't need to have that. We do experiments and it appears that we're synthesizing elements, but the world isn't ending, because what happens is when you form these coherent matter structures, the nuclear reactions occur inside, and when the coherent matter structure collapses, well, they just pop out. And I can show you what happens because there's even photos of it. And I'm going to show you right now. Yeah. I'm going to show you in a paper by, it's a book. I have the book here, which I remastered. It's the Steps to the Discovery of Electronuclear Collapse by Takaaki Matsumoto. Sadly, he died earlier this year. I did get to visit him just before he died. And the key phrase in here, which I must read before I show you an example of what happens in these spheres, and we've replicated what he showed. Far in the universe, nuclear collapses very often take place by the gravitational force after stars consume their fuel. That'd be when a black hole happens, right? Since the electromagnetic force is about 40 orders of magnitude stronger than the gravitational force, it should be easy to induce similar nuclear collapses by electromagnetic force in laboratory. But we never knew until now how to do that. Recently, the author discovered a nuclear collapse which was induced by the electromagnetic force in laboratory during study of the mechanisms of so-called cold fusion phenomena. Several kinds of nuclear reaction which were directly induced by the electromagnetic force called electronuclear reactions were found so far to occur in a special state of hydrogen clusters called itonic clusters. This is his idea, or micro ball lightning. The nuclear collapse was one of the most remarkable reactions among ENRs called electronuclear collapse, ENC. Furthermore, very amazingly, completely broken materials by ENC were found to be regenerated again to thin tubes and films of conventional elements such as carbon, oxygen, and iron. The latter process was called electronuclear regeneration. So, you can push this so hard that all of the matter is converted to field forms of matter. And there's a guy called Kladoff, and he actually did this between 1999 and 2002 using sound cavitation. Completely destroyed matter, converting it into just waves. So we observe things disappearing. John Hutcherson observed things disappearing inside of the metals. Here, in 1990, I think it is, published here in Fusion Technology, the American Journal of Fusion Technology, using palladium electrodes loaded with deuterium, Matsumoto cut them in half. And do you know what he found inside? The material had disappeared in spherical sections that started along the grain boundaries, like this, and grew and then consumed entire crystals. And he calls these, ultimately, microball lightning. Here, he describes the process here, how it occurs. And the reason is because you get a concentration of electrons and hydrogen atoms at the grain boundaries, and you end up forming these clusters. Okay? The same thing occurred with John Hutcherson. And ultimately, if it's consuming the whole crystal grain boundary inside, where is the matter going? Well, if it goes into electromagnetic waves, or it goes into neutrinos, it can leave the matter and you don't even see it. You don't see it. So, go on.
On that, then, if you don't mind.
Yeah, go on.
So I think there are two quick questions on the topic here. Is that so? There's a zap where there's a flash when we see in our MH370 videos, at least in the satellite video. Do you think that might be indicative of this type of process? And a follow-up question would be, how much energy do you think would be required to induce this singularity that we see?
Very little, because it's self-feeding. Once you get it going, it does itself. So let me I can show you a video.
Amplifying it, is it able to amplify it and ramp up? Is that a good understanding, or how would you describe it?
So here's the thing: if you have a bubble in which you change the ability of electric fields to form, what is an atom? An atom is a nucleus, let's say. It's a little thing in the middle, and on the outside you've got a whole bunch of electrons, right? Now, the electrons are the electrons are attracted to the positive nucleus, aren't they? Yeah? Because you've got a positive charge in the nucleus, because you've got some protons. Forget about the neutrons, they don't help, right? You've got the electrons on the outside. They attract it. But what stops the electrons collapsing into the center? Well, they repel each other, right? So there's a happy equilibrium that they form. Okay. Now imagine you change epsilon zero, the ability of the dielectric constant of the physical vacuum. These things can now, the charge doesn't work in the same way. So they can collapse in. And if they get all the way into the middle, you get electronuclear collapse. The electrons become part of all of the protons, because in every atom that ever was, you always have an electron with every proton. It's like the simplest one is hydrogen, protium. It has a proton and an electron, like that, right? If you have deuterium, it's a proton and two neutrons. You still only have one electron. So for every proton, you have an electron, whatever atom you're looking at. The ones you're made of, the one the plane's made of, the one the lithium ions batteries are made of, the toothpaste in someone's, everything's got, for every atom, new proton, there is an electron. Yeah. So if you change the dielectric constant, then, and the electrons can't repel each other in the same way they do, well, they collapse in on the nucleus and it becomes a collapsed object, a fully collapsed object. And you're going to see this when I show John Archibald's comment. You're going to see, everything you need to know is in that short comment to explain what you're observing. Now, if you wish, I can show you a video of what happens when an exotic vacuum object goes boop, because we've got it on video. And you'll see that it looks a lot like you see in your videos. Let me do this. It's one of the first videos I shared on my blog.
Sure.
And the crazy thing is, when these things blow up, they actually leave a cold thing. So what happens when matter is collapsing in, and this happens at electronic speeds, people can't conceive of the speed at which these kind of reactions occur. They happen so fast. It's mind-boggling, right? You think when a hydrogen bomb goes off, it goes from nothing to like a big freaking thing that's miles wide in a blink of an eye. Well, look at how fast they claimed that the universe went from something the size of a pea to something the size which is unfathomably big. That is kind of, when you're talking about these reactions, they can occur to all intents and purposes instantly, okay? And there are many things going on at the same time. So I'm going to share this one, if I can drag this down. And it's called Evo Blaster. And you can see it here. So I need to actually share, don't I? That would help. You can't see, the people on my channel can see. Let me share that here. Okay, so essentially what you have is you have these flashes, and then you have a cold zone left over, right? And so this is an exotic vacuum object, but it's reached the point at which it's now detonating. And so if you look at Matsumoto's work, he talks about on page 91 that when the black hole explodes, the explosion of a black hole here, you get a carbon film forming, but you also get this wormhole, and the matter comes out somewhere else and is reborn as other elements in electronuclear regeneration. I can show you, actually, because I have it somewhere here. The biggest mess ever.
So real quick, in that scenario, though, it's matter is coming out somewhere else, right?
Yes.
So for something that's the size of a 777, shouldn't there be some byproduct somewhere?
Yeah, but it might be in the middle of the Earth, and it might be in some galaxy far, far away.
Yeah, okay. I get it. Yeah, so it could be somewhere else that we're not seeing, basically.
I prefer the second option, which is using the 1979, the same year that I saw these balls in the sky, propulsion technology that was proposed to NASA by A.C. Holt, which has the fractal toroidal structure in there. But before we go, though, I just want to close this out by showing you this diagram on page 91 here. So you can see it a little bit clearer here. So this is his concept, having studied a lot of particular pieces of material. You have this zone at which the explosion spans out to, and that's the point of electronuclear collapse, and then through the wormhole, and you have the emission from the white hole. So it may well be that this will go down to ground, and whatever was originally in the matter, it's now inside the Earth. And
heard about the eruption of the white hole is very interesting. I was talking about that with Salvatore Pais. And just real quick on that, just a side note, you don't have to look into it. What do you think of Pais and his work? Is that, you think it, it's similar to your work? Do you think there's differences? What are your thoughts on that?
I think it's definitely well researched. I don't know how original it is. I do know that in 2017, when I realized I had to either walk away from this science or actually because of the implications of what I was finding, or move forward. And I only moved forward because it was obvious to me that this had been weaponized and it was only going to be used to subjugate humanity. And so I thought I will take a full-on reputation hit. I don't care. I have no choice for various reasons, which I've explained in the past. I knew I would always have to do this, and that it wouldn't be something anyone would be particularly happy with me doing. And I will say on your podcast for the first time, just before I released a particular presentation, I looked into the camera and I deliberately looked like I'd lost my mind, but I was acting. It was to gain a bit of buzz, right? But the point was, genuinely, I was also in shock as well, so it was easy to do. But I said, I don't know how these people can sleep at night knowing what they've done and that they're hiding this from humanity. And you know who they are. And I said, you have got a few years to come clean with this. And that was in March 2017. I said, you better come out and be public about this, because it's going to come out now. It's going to come out. And one of the particular parties I was referring to was the US Navy. And that's the first time I've said it. It's absolutely crystal clear that they've had this technology. And the evidence is already there in the record.
A long time, probably, too.
So the other thing is about Salvatore Pais. I've already done a presentation where, I visited the Hutcherson lab, which is in a secret location in Germany, his previous lab, which has been reconditioned and stuff, and they're waiting to operate it, having the skill to do it. And if I just stop sharing for the minute, in there was a sample, and I pull it, and this is before the Pais patents were released, and I pulled it off the shelf, and I said, what I believe is going on here is there is a piezoelectric material, and the electromagnetic waves interact with this aluminium block and form phase conjugation and coherence in here, and this is the basis of what's going on that's producing the Hutcherson effect. The reason I said that is because in the late 1950s and published in New Scientist in 1963, they showed using a piezoelectric material called quartz, which I referred to earlier in a number of different cases. They used a magnetron to produce electromagnetic waves. That goes into the piezoelectric material, which can convert the electromagnetic waves into phonons at the frequency of the electromagnetic wave, and it travels down the quartz, it comes off the other far side and reflects back, and you get these little blips as the sound, which is at the frequency of, let's say, 2.45 gigahertz. That's the sound. It's sound, but it's weird to think about it. It's like so ultrasound, it's unbelievable. And what they found is that if you go to 10 gigahertz, you actually start getting sound which is at the same frequency, or rather in same periodicity as the interatomic spacing. Okay? And this leads to you be able to create phase conjugation at each atom nucleus. And because as I said earlier, the electrons have a relationship with the nucleus, right? The nucleus is held within a shield of electrons. If you squish that on the electrons, because you've got a phonon coming through, a sound wave, it's going to affect the nucleus. So you're going to get standing waves, right, in there. And so what this means is you can make coherent matter. Now, what would be the best choice of element to make coherent matter from? Well, it would be one with a single isotope. What is that? It's aluminium. That is what is in the Salvatore Pius. He puts PZT, lead zirconium titanate, a piezoelectric material on the outside of aluminium, a monoisotope. He then hits it with pulses of electromagnetic waves. Why is that doing what it's doing? It's creating room temperature superconductivity, because it's converting that single element isotope by using sound waves, which are effectively scalar, at the interatomic spacing. It gets them all into phase. And when you have all of the same matter wave in phase, the whole thing becomes superconducting. And it was published in 1963.
Now you've got a superconductor. So, and I agree. I think that a lot of Salvatore Pius's famous patents, obviously, it leaves on all types of science that's been.
Of course, it has to.
So you've got that superconductor. Yeah, go ahead.
No, it's fine.
I was just gonna say, you've got this superconductor now. So is that like kind of the mechanism by which all the rest of this is possible? Then?
The thing is,
if one leads to the other, how does that work?
Okay, so let me get the Lockheed Martin patent. It's the right time to bring it in now.
Sure.
Yeah, am I sharing my screen, or what's happening here? I'm not sharing my screen at the moment. That's okay. So
you're not sharing it. No.
That's okay.
There you go. Yeah.
All right. So I need. Is it down there? Okay. So if you go to my blog at remoteview.icu and go to just type in coherent, probably that'll do it. Maybe there. It's the first blog article, public blog article, and it's the Aharonhof bomb effect, or the Bohm-Aharonhof effect, and how it relates to so here it is. It's called Systems and Methods for Generating Coherent Matter Waves. There we go. United States patent. This is probably one of the most important patents here. Understanding this. So this is filed December the 28th, 2011. Okay. And it was prior published on July the 4th, 2013. And so here you've got a magnetic field, you've got some microcavities here, you've got cathode, which is emitting charge clusters in exactly the same way. Sorry, I'm not sharing my screen, am I? So I'm talking to myself. Okay, so here it is.
Okay. Have your other one up. I'm watching your stream at the same time.
Okay, you're all right. Cunning. So here it is. This is Systems and Methods for Generating Coherent Matter Wave Beams. Okay. There's the file, December the 28th, 2011, and it was first published July the 4th, 2013. Okay. I think the date of patent here, I think maybe this is awarded 22nd, 2016. I only ever saw it in 2017 or 18 or something. Anyway, they emit electrons via spike electrodes with a pulse. This is exactly the way that was done by Tesla, and it was exactly the way that was done by Tesla in his electrical particles of matter weapon, as described shortly before he died. And this is the way that Ken Shoulders did it. They pass through a magnetic field with these coupled resonant cavities, and this forces coherence along with the magnetic field, and you get a coherent matter wave, right? And this is the moment that was the aha for me. Firstly, this is the structure, right? Okay, and this is a ball of coherent matter. Okay. So they talk about how you can so furthermore, unlike laser beams, the Bose-Einstein condensate, e.g. a form of coherent matter wave, the subject technology may produce coherent matter waves that allow both fermions and bosons to achieve coherence. Okay. According to various aspects of the subjectology, a system for generating coherent matter wave beam is provided. The system comprises of a plurality of beam generating units disposed. Each of the plurality of beam generating units configure a generated stream of charged particles, and so on. Okay. According to various aspects of the subject technology, intense directed coherent matter wave beams of particles for bosons, e.g. particles with integer spins, or fermions, e.g. particles with half integer spins, neutral or charged, may be produced. So basically there's no restriction. The energy stored in these beams may have virtually zero entropy, allowing for experimental physics with unexplored territories. Coherence in matter waves, in particular in fermions, may be beyond the reach of conventional technologies unless the temperature can be reduced to near zero. However, even this approach may only work for bosons using conventional technologies, blah, blah, blah. And then it goes on to explain, you can read it yourself, but it goes on to explain that in this technology, you do not need to have near absolute zero. It can be at any temperature, only in the, as I was describing in the early part of this. But I want to talk about the applications here. Furthermore, coherent matter waves may allow fermions, electrons, as well as boson to achieve coherence. Example applications. I'm going to zoom in right here because this is the money shot. All right, well, maybe it's not going to let me, but because I'm in there, it doesn't matter. Examples of applications for coherent matter wave beams may include single bath thermal energy extraction. What is this? This is like sucking energy out of an area in free space, where you couldn't ordinarily do it. Normally you need a temperature differential to capture energy, right? Using this, you can literally, it's like a black hole. You can suck energy out of something. This is a terrible weapon, actually, but in all by itself. Ultra-sensitive accelerometers, interferometric tracking of air and spacecrafts. You can literally move this to track these objects, okay? In very difficult things that you can't track in any other way. A more accurate alternative to global positioning systems, matter wave projectiles.
Wow.
Right? And this is not...
So is that teleportation, or is that something different? What do you think? Well, how would you define matter wave projectile?
This is a ball of intense clustered energy that you can fire. Huh. And because it has its own substructure that allows it to be in its own space-time, it loses its mass and inertia. And so you can accelerate. If you leave it with a little bit of negative charge, you can use... So Ken Scholz has described how just using 240 volts from your domestic power socket, you can accelerate a whole incredible volume of energy to 1/10 of the speed of light just with the field generated by a normal electric socket. You don't need a huge linear accelerator, okay? Because the mass is completely removed and the inertia is removed, okay?
Yeah.
Missiles.
With the inertia, you don't need a ton of power, right?
No, you don't.
Go ahead.
You can accelerate something phenomenally fast with a low field, okay? Not only matter wave projectiles and missiles, directed energy weapons. Notice that's different from matter wave projectiles and missiles. Directed energy. So what you can do is, in my presentation at Szczecin, I showed what cold electricity is. It's a toroidal cluster of electrons in this condensed state, which then is guided down a wire. So this was shown, and it's in Bearden's book. It was shown to Bearden in 1992 in Moscow. Right? Using an 8 micron wire, you can transmit 25 kilowatts of power. And what is happening is the structure is guided down the wire by the field, and it carries far more energy, but the energy is in a pseudo superconducting state relative to the wire. The wire is just the guide. Now, there's another way you can make a wire. You can make a wire by using a laser to ionize air. And then the charge cluster travels down the ionized air channel as a wire, a virtual wire. So that is your directed energy weapons. Okay, you can direct, but there's also other ways you can do it. You can. So Ken Scholz talks about fluidized electrons, which we have created. You can send those fluidized electrons to somewhere. They can go into the metal, and then you can direct what happens to them. You can get them to detonate all in one go and shred them at thing, or you can get them to destabilize and turn the metal to jelly. There's all kinds of different ways you can manipulate them. This is like, it's like magic, and you send off the package of things that you can then ask it to do various things with, right? Matter wave optics. So with matter wave optics, you can literally change the dielectric, not dielectric properties, the refractive properties of an area of space. So you can create a virtual lens in the sky. You know, if you wanted to lens sunlight, for instance, you could literally create a lens that's not physical. You've just literally created a lens in the sky. So I always remember burning. What do you call it? Ants. When I was a kid, I got over it. I felt too guilty even with an ant dying, but like they were quite annoying. There was a lot of them. Apparently, they're like 1/10 of the all animal biolife on Earth is ants. So you know, I've kind of got to come to terms with my killing ants. But yeah, you can use a magnifying glass to just burn ants, and so you could, in theory, create a virtual lens in a free volume of the atmosphere to, you know, direct sunlight, as it were, in the same way that I think the Greeks or some ancient civilization used mirrors to burn ships. They would have these big copper mirrors or something, and they would point them all on one ship, and they would set light to it, right? Cloaking. You can use this for cloaking, right? So you can track a cruise missile and then make it cloaked, right? Matter wave emissions and propulsion in there using this matter wave soliton.
Part's getting me.
Oh, I know, and then I'm going to show you how it's done. Matter wave solitons, high energy collisions, and high precision matter optics atomic clocks tests for physical contents and other suitable applications. This is the money shot there. This is kind of a rough idea of where you might want to use it, but it's the applications are mind-boggling. It's literally a whole new era in science. And this is 2011 this was submitted, just as Ken Shoulders said in 1987. In 1987. Okay? So, I'm going to throw a couple of papers at you right now. So this is Force-Free Time Harmonic Plasmoids by Jack Nachamkin, and he is at the Phillips Laboratory Propulsion Directorate at the Air Force Material Command, Edwards Air Force Base. And this is from 1992. It's a fairly long paper, but you can get it free. It's publicly available. And it talks about these structures. A heretofore unexplored solution of Maxwell's equations is investigated for time harmonic waves in particular ionized gas. The analysis is focused on the spherically symmetric cases that behave like electromagnetic energy trap. Okay, you're going to hear the word plasmoid a lot. Okay, it will be shown that a critical frequency exists below which the current cannot be carried by electrons and the plasmoid remains stable. Resonant sizes will be shown to exist such that the plasmoid will not exchange energy with their external surroundings. You can build these things, you can eject them, and they're not going to dissipate any energy at all, wherever they go. You can get energy in there, there's ways to get energy in there, but once you've made these things, they're in their own little bubble of space-time. And their boundary conditions can be met by vacuum solutions to Maxwell's equations. Virial analysis calculates free charge density, blah, blah, blah. What do they look like? Well, firstly, under different conditions, they may have names like anomalous discharges, charge clusters, and ball lightning. I'm telling you, this is what it is. Now, what happened to Matsumoto is he was happily publishing in the American Nuclear Society's Journal of Fusion Technology until 1993, when he started correlating this phenomena with ball lightning. Then they changed the rules, preventing him from being able to publish. Then the Air Force, under J.R.R. Roth, in the following year, it was submitted, and I think it was published in May 1995, submitted a paper that said ball lightning can teach us about fusion technology. And if we can create a 10 millimeter ball lightning, it would provide all the energy for a home. That was in fusion technology, after they'd prevented him from talking about ball lightning. Now, Ken Shoulders was asked, tried to publish his thing in our field. Our field is condensed matter nuclear science. Ken Shoulders was prevented, A guy that worked at Los Alamos National Laboratory demanded the curator of the library of files on cold fusion, called at lenacana.org, to remove Ken Shoulder's work from the database. And I never heard of Ken Shoulder's exotic vacuum object / ball lightning work or Matsumoto's work until I mentioned them for the first time in 2017, since I started working in the field from 2012. It's crazy. So this is ball lightning, and what does it look like? It's a sphere like that. They don't know about in 1992, they didn't know or understand in the West about the internal structure. And it forms this spherical object, which is at quantized level. The maths is in here to show the stable quantization levels, and it tells you about what's on the skin of the plasmoid. And you know the superfluid nature of it. So here we go. There's a couple of images, like spherical plasmoid. Figure 2, matching plasmoid boundary conditions at the surface of the plasmoid. The electric and magnetic fields are parallel and tangential to the surface. This can be exactly matched by the external vacuum fields. So they're stable structures. Once you make these things, they can fly through water, they can fly through the air, they can fly through space. Okay? Now, you...
Stable, right? Pretty much just go and do whatever you want for any period of time, right? So you could deploy it, you could have it just float around, have it being controlled, and it's going to be perfectly stable.
So our understanding is... I'll show you a slide from my presentation, and then it'll help me to help you understand how this thing can be stable. So I need to go here. It's not that one, is it? Windows, that one, and then I need to go present to view. Okay, and I want not that slide. I want. So this is what I was talking about. The Penrose stairs. Okay, going round and going round. This is a phase singularity in the center here. You're not actually going up or down, and you get that with a Mobius strip, and then you get that there. And this is what I was talking about, single bar thermal extraction. That is a Mobius strip in there, and it's extracting thermal energy at a distance from here. Okay, and this is fusing matter because it's yin force, so it's not as bright as destroying matter. The yang makes a brighter flash because it converts most of the energy, but it still projects out to a different place. Okay. Anyway, what I was going to show you was what was I going to show you? What was I going to show you? Here we go. So
asking about so I'm kind of going back to the videos in terms of the balls and
here you are. Here you are. So in the top left there, you have the basic structure. It's a torus with a magnetic pseudo monopole and the electrons coming in or the ions coming into this phase singularity where it can't go out here. This is the overall fractal structure.
Yeah.
And I then found this in Henk Uren's experiment. This was the first one. We found many, many since. And this is the collapsed matter wave function.
Oh, wow.
Okay. And it's calcium oxide. Calcium and oxygen and calcium oxide are all paramagnetic. They can all live inside this highly magnetic structure. But outside, it has copper here and carbon here. These are all diamagnetic. They cannot go across the boundary because they get repelled by the intense magnetic force at the boundary. Okay. Now, I showed these three to the Russians that I have a regular meeting with, and they immediately sent back this. And this is an image from a paper in the Biology of Life by a guy called Zverblis. And Zverblis was invited because he was interested in DNA and coils of coils and how you could make because DNA is a coil of a coil of a coil of a coil, right? He thought that if he started making complex coils, he could interact somehow with DNA. And so this word got about, and so he was invited into this Moscow basement in 1988 and shown this technology, which looked like you see here, where I've got my mouse. And what they did is they put 30 hertz AC through this, and they showed on a fluxgate magnetometer an AC magnetic wave in the center of this structure. And then what they did is they turned off the power, and it still persisted. And then what they did is they moved the device where the center of it had this AC magnetic waveform. they moved it over to the side, and in the free space that it was left behind, it still had the magnetic AC waveform. And that this persists for 2 days, even when the power's turned off. And so he thought, well, this is crazy. You're obviously pulling some trick on me. I don't believe that this is real. So he went to Nevesky, and I've translated both of these papers on my blog. And he published, although it was confirmed in 1988, he only published after the end of the Soviet Union in 1992 in the peer-reviewed journal Electricity. And essentially what he found was, using standard Maxwell equations, if you have current going round in a loop, you produce a magnetic vector through the azimuth. If you have these and you rotate them 90 degrees and put a loop of those, you have a magnetic loop with an electric field going through the azimuth. If you take that structure and you rotate it 90 degrees and put those in a loop, you have now another electric loop with a magnetic field. And this can go on indefinitely. That is exactly what I described in 2020, having derived this structure from looking at impact marks on the John Hutcherson sample. John Hutcherson being the same guy that Ken Shoulders developed charge clusters from. Okay? And so what they found was...
You just showed there, was that what you said, the fractal toroidal, or is that how...
This is fractal toroidal. This is fractal toroidal. Yeah, so like here is the basic fractal toroidal structure, and what happens was I looked at this microscope image and I found different quantization levels. So this, rotate that 90 degrees and you get this structure. This is the apple core running through the center. And if I take that structure and I'm looking at it from the top, I see it here. Now that one, if I take that and I rotate that 90 degrees, I ended up with 48 divisions around here. And that's how I got to this structure. And then we saw them as impact marks. This is 4. This is 6, this is more. So we see these structures, and these are clap structures. This is 36. This would be 48 if it was a full tor. This is 3 in the subtor here, and this is 3 in the subtor here. Okay? So these created this structure. And so what it is, if you have electromagnetic... if you have current going from... I'm going to stop share right now because it's just easier to do it with my arms, right? If you have electricity going through a wire, the pointing vector comes off and the energy is dissipated. If you're going through a coil, the pointing vector comes off and it's dissipated. If you have a coil wrapped into a coil, then the pointing vector comes off and dissipates. But if you have a coil in a coil, then the pointing vector goes into a loop. And so none of the energy is dissipated. And you can keep putting energy in and it gets trapped in a vacuum current. Now the word vacuum, the phrase vacuum current comes from, this was established by Nevesky in 1988, published in 1992 and released to the West when the Soviets threw in the towel when I sent them these 3 images. Basically, if you have a coil of a coil of a coil of a coil, that then has a loop of pointing vector there and a loop of pointing vector there at 90 degrees. And if one collapses, it re-energizes the other one and vice versa. And so you have a stable exotic vacuum object. It's a energy concentrated at a point in space-time which doesn't require any physical matter at all. And it can be... Now, David Freiberger at the SLAC, Stanford Linear Accelerator, he calculated independently the same thing that Nevesky did 2 decades earlier, or whenever, in 2009, when he was trying to explain ball lightning floating around in the superconducting cavity inside a national lab in the US. And he calculated that the energy concentration caused by this standard Maxwell equation derived phenomena could lead to vacuum decay. That is to say, it would knock a baryon off its reference to the Dirac sea, and it would fall apart, and the baryon would just fall apart. Okay? So I'm sorry to say, and by the way, this is what one looks like when you make it. So thank you to Cosmic Dave for making one in the UK. So here you can see you have a coil wrapped into a coil that's wrapped into a coil. There we go. He developed a winding machine to make these things. These are a weapon. They put them on parabolic dishes and then project them. That's all I'm saying. That's all I know.
So
I've not seen it.
What you were showing Pat earlier, that's how you can enable all those functionalities that we were seeing there.
I don't know. But I'm going to describe this. So look here. I'm going to go back to sharing my screen. Share screen, and we'll go here, and I will do that one. That one, yeah. Share. Right. Could you see my screen again?
Yeah.
Okay.
I think it's started right now.
So, around that, around that ball lightning section that was cut, this disappeared. This in a flash disappeared. Right. You can go and look on the MFMP's YouTube channel, Martin Fleischmann Memorial Project's YouTube channel. You can see the beautiful pattern that the coherent matter creates as it bores. It's like loads of tubes running through the copper, and next to it, the copper is not melted even slightly. It's like scalloped out. It's incredible to see, right? But just on the boundary, you have these fractal toroidal structures of different orders of n-1 level tors. So on this one, you have 2 making the structure. And you can see the material in the center has disappeared. Here you've got 3. And in the center, you've got this like paisley pattern. And the material in the center has disappeared. Here you've got 4. And you've got the material in the center. And it's disappeared. Okay? So in each case here, you only need 3, as I said, because 2 you can't define a plane from. And Bostic was the work that I told you about. Bostic trying to make the fusion. Here are his impact marks, published in 1980, and he says a D4D ring with spokes under the surface. It's the same thing. This is what it is. Now, in a paper which I will show you here, have I got it? Hopefully I got it. Yes. This is the 1979 paper by A.C. Holt called Field Resonant Propulsion Concept. And by the way, in this paper, it lists every single thing that you've seen supposedly disclosed about the behavior of unidentified aerial objects in recent congressional testimony. You can go and read it in this document from 1979. It's like, and I literally mean that. So the speculative propulsion, the speculative propulsion concept described in this paper was presented at a special session of the 15th Joint Propulsion Conference in June the 18th to 20th, 1979. Propulsion Concepts for Galactic Spacecraft. This concept was developed as a result of private unofficial research. NASA is not involved in the UFO research. We've got to clarify this because NASA doesn't want to be involved with that, okay? However, the research which may be stimulated by this paper could result in the verification of the essential elements of this concept and the feasibility studies concerning the development of a new generation of NASA spacecraft. Okay. Electromagnetic waveforms, gravitational waveforms, or space-time metrics. The propulsion system utilizes recent research associated with magnetic field line merging, hydromagnetic wave effects, and free electron lasers. Laser generation of mega-Gauss fields. Okay. So it talks about alpha waves and, properties of the Earth here. But here is the money shot. This is the money shot. This.
I think you might be sharing the wrong.
Am I?
I'm not sure.
Oh, am I? Let me try that again.
Yeah, I think so.
Sorry. This one. This is the money shot. Can you see it?
No problem. Yeah, it should be coming up here in a second.
Can you see a torus with things?
Maybe. There it is. Yep. Now I can see it. Yep.
Okay. So this is a current loop, 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 a current loop. That makes a magnetic loop. That makes a toroidal moment. This is a real thing. You can go and look it up on Wikipedia what a toroidal moment is. Now, look at the magnetic field line reconnections. They connect and end up producing a magnetic vortex in the center. And that creates your phase singularity that allows for coherence at the center point. Now, what's going around that plane is one of the 3 of these. Actually, not one, because they didn't know what a toroidal moment was in 1979. It wasn't verified in the West until 1997, right? So they were so far behind the Soviets. Okay, but this comes to my second hope. Not that the matter is destroyed, like we seem to be able to do fairly readily in a range of cold fusion experiments and our own experiments, and have caught on camera. I hope that it's packaged itself into one of these bubbles and it's used this as a drive to move it to somewhere else. It's not teleported.
Interesting.
It's not teleported. It's changed the space-time metric so that it has no mass or inertia, and then you can move the next tor up as if it was one tor below with no effective mass and inertia. You can move it around by the same way you move the one above. But when it collapses, the problem Go on.
I was just going to ask, so because I mean, what you just said there was a pretty big bingo moment for me, right? It's like you reduce that mass and you can move on. Can you move it in any direction if you do that, or are you limited in the direction?
Everything you see, the balls that come in can do, you can do. Everything that you can see any of these spheres do in any of the reports ever, you can do. They can move in any direction, and there will be no inertia inside that bubble. So they can be going along like that, and instantaneously they could go underground, they could go up into space, they could go forward, backwards, immediately, as soon as that structure is formed. And the interesting thing is, time will slow down or stop for the participants in there. And like I say, and Ken Shoulders in his writings has clearly demonstrated that you can go with a small field at 1/10 the speed of light. Well, it would take you no time at all. And also, you could stop instantaneously. Now, I was describing sometime earlier today, we were at the Technical Museum here where I live, and I was saying, look, you know, there's a real problem if you get in a car accident, even at 75 miles an hour, because your brain hits the dashboard, right? Sorry, your head hits the dashboard, your skull stops immediately, but your brain keeps moving forward, and it turns to mush, right? So, like, you can't decelerate, but you can in this. You can decelerate instantaneously. So you can go from 600 miles an hour, capture it in this little bubble, move it at 1/10 the speed of light to another point somewhere else, and stop it instantaneously and gently lay it down on the ground. And then you have a method for decohering the structure. And it might go, and just go. You hold it like 1 millimeter above the ground.
Isn't the object in the bubble going to keep moving at the same speed that it got put into the bubble, or is that also able to be modified?
Well, I'm sure there's ways to get around that. I'm sure there's ways to get around that. Effectively, it as soon as it's captured in that thing, it's relatively in that thing. If you know what I mean. Otherwise, you're kind of arguing that it should punch its way out. No, it doesn't. It's stuck in there. It's locked. It's literally locked. So it's stuck in there. Now, I'm going to...
think that if there's any, one more thing real quick on that, because I think you talked about fermions and bosons and converting them. You know, are we talking about a situation where you convert them back? And if I'm talking about the videos, I guess what I'm trying to figure out is, like, could the occupants still be alive based on what that's happening? Can the plane survive the event that happens there, or is it going to be, deconstructed, destroyed? What are your theories on that based on...
If you get this wrong, the most likely thing is that the matter is converted to other matter, right? Just that's what will happen, right? That's what we see. It appears in physical experiments. So you don't want that. The fact that they were discussing exactly the toroidal moment as a means of intergalactic travel back in 1979, and they were right. This is exactly what you need. It's not approximate, and I'm not a time traveler. I didn't tell them to go and put them in this proposal, right? And when you look at the associated papers with this, there's an associated paper from 1976, and they fire a laser in Japan into a nonlinear plasma, and they create toroids in the plasma with internal magnetic fields of over 1,000 Tesla. That was replicated and funded by the US Department of Energy, the UK, the European Union, China, South Korea, and Japan, and published in 2021. They replicated the phenomena. They found that it produced, in their ones, if it was 20-something microns across, it was something like 1,360 Teslas. Okay, and bearing in mind the biggest MIT superconducting magnet is 50 Teslas, right, for doing fusion. Okay, this is 1,300, and they note that the smaller it gets, the far higher the magnetic strength gets. Okay, and I will show you this because I have it in my presentation here. When I get there, am I showing my screen again? I can't tell now. I've got so many things up. What am I showing? Okay, all right. Okay, so let me go presenter view. Here.
Yeah, I'm gonna need to wind down here in
okay, well, okay, so we come into the real money shot here.
You want to try to conclude? Yeah, go ahead.
Yeah, so here is this laser paper. This is the laser paper, and it was published in Physics of Plasmas in 2021. And as this gets smaller, the magnetic field goes up. But note, here is your toroidal vortex motion on this back plane here. Here is the magnetic fields at 1.36 thousand Tesla. But also there's a magnetic field that comes to a hard stop here. Okay, now we already know that ions and electrons will come in here, or matter will be pulled in here. Oh God, there's so much I need to go through. But anyway, all right, fine. This is the phase singularity. You note that the magnetic field literally stops here. It stops. That is the magnetic singularity there. The phase singularity. It stops. That is the magnetic core. Okay, and that is the same place at which the pointing vectors close. So you get electromagnetic and everything. The gravitational wave comes through the center, and you're going to know this in a minute when you listen to John Wheeler. You know that the gravitational wave's coming through the center. You know the electro and magnetic fields are coming here, and it's a singularity. This is where you get the singularity in terms of unification of the forces at this point. Okay, so we're going to listen to John Wheeler. Hopefully you can hear it, because I'm going to move my mic down. I don't know whether it'll pick it up. Let me know if you can hear it, and I will stop it at relevant points. It's going to let me do it. Is it going to let me do it? Is it going to let me do it? Why isn't it let me do that? Oh, okay, that's going to not help. That's going to happen like that. Come on. Okay, I might need to get that video separately. Bear with me. If you have any questions now, fire them to me and I'll get that video up.
Yeah. So I think that really, just to kind of sum it all up, I think that what the audience really wants to know is your thoughts on kind of the effects, even so much as I think we appreciate the science a lot. And I hope that the academics who are watching will, look at this and take it very seriously, because a lot of people wonder, and they think, when we talk about this kind of stuff, that they think that it's not proven or that it's not supported by science. But I think as you've done here, you've shown that it absolutely is. And it's proven by science. It's been out there for decades. So I think that from a perspective of the videos and the MH370 videos, what we kind of want to know is it's possible. What are we looking at here? I think what I've heard, and I'd like to hear your thoughts on it, is that we could be looking at an annihilation event. We certainly could be looking at, I'm going to still call it teleportation, but I think that really it's more complex than that. It's a situation where we can move an object, a matter wave can be moved around freely, just like we see these orbs move around, ignoring gravity. The inertia could be stopped entirely. We can have it, put it down wherever we want, theoretically. And to me, that's very powerful, because it answers a lot of the questions I've had about the videos. And that's why, before I let you speak, I just want to say I appreciate you and the time and going through all this. So did I get that right? Or what are your thoughts just from the straight up, kind of what could hypothetically be happening scenario?
Yeah, so I very firmly believe that there's two most likely options. One, total annihilation, and I believe that this was developed as a weapon to remove projectiles. I believe this is why they don't care about Kinzhals. Like you say Putin gets up and he says, "Oh, if you move your carrier groups next to Israel, we'll be able to launch Kinzhals from our Black Sea fleet, from our aircraft." And it's like no one even bats an eyelid. Why? Because it doesn't matter if it's going at Mach 13 or 14, because we can literally make them disappear, and it's the perfect technology. Why? It doesn't matter whether you've got a dirty nuclear bomb or a fusion bomb, a thermonuclear bomb. A thermonuclear bomb still has plutonium in it, like a nuclear bomb. It has a plutonium trigger. If you knock these out of the sky with a missile or a tungsten thing falling down from a satellite, firstly, you only have as many missiles as you have tungsten things coming from the satellite. It's not an electromagnetic system. Which you can just recharge by getting a bit more sunlight or nuclear charge on board. You have a situation where you have raining down one of the most toxic substances to human life, which is plutonium. And it's got a half-life of like 238,000 years or something ridiculous, okay? So this is going to be a problem for a very long time, every single bomb that rains down. But if you have a system that literally makes that matter convert whatever it is into light and leptons, which are all very friendly, right? It's not a problem. Nothing rains down. It's the literal perfect strategic defense initiative, right? The perfect one. Wow. So I honestly, my gut instinct, this is likely a technology that it was developed for destroying intercontinental ballistic missiles and now Kinzhals, and that's why America is way behind China and Russia on this, because it doesn't matter. And I have been saying this for years, long before I saw your videos. I've been saying they don't care about these weapons, and I believe that the Russians are onto this because their next generation of fighter jets will have no metal in them, so they're less prone to being affected by this. You know, they will have actually no weapons on them, nothing that will have metal in it if they can get away with it, right? So there's that.
Yeah, real quick, can you switch your screen to stop and put short faces?
Oh, yeah.
Talk about this?
Yes.
I want to potentially clip this as well. I think that, so just from the aspect, right, is you just mentioned that you could have a perfect defense, some completely wipe out a bomb, missile, anything that's coming.
I've said for years, in short.
Null.
Yeah, I've said in short that I do not. I have argued that the reason they don't care about Kinzhals and upgrading their nuclear arsenal and stuff is because they already have a solution. And I've said that they can knock these things out, and I've quoted this number. They can knock them out at 1/10 the speed of light. So who cares about Mach 14? You know, they can get these things, generate them, move them to any location on Earth at 1/10 the speed of light easily. I mean, you can go faster, but easily. And then literally, and I've literally said they can make the things disappear. That's and it's recorded. I don't know which videos, and I've said it a number of times. So they don't care about it. And then when I saw your video, I go, there you go. There you go. That's it. And it is the ball lightning structure. It is the monopoles. And when I will get this Wheeler video, and we have to close with that, it is all you need to know. This is the guy that worked on the Manhattan Project. He was the tutor of Feynman, and he is the person who's attributed with talking about black holes and wormholes. And what he describes, when you know there is a gravity, because we've shared these videos, you can go and look at them, called extreme interactions. Go and look at those videos. You can see when one of these EVOs is moving in this direction, not caring about any electro or magnetic fields in the reactor. Another one comes over from here, and within an event horizon, it starts orbiting around it, or gets kicked away. But more interestingly, it does it in its forward directional path. So you have one coming over here and it starts orbiting around before it's even got it. got there. So you know that there is a spin field coming out in front of this structure, right? Now, when those things are coming around the plane, they will not be pointing in any direction that will allow them to link their gravitational waves together. They will be arranging so that they have the center in that Vesica Pisces out to the destruction beam there, and they will be pointing forward ideally, but they can move around as long as they don't link in a loop, like I showed you, right, in my 3D visualization. They mustn't link their gravitational layer. And I'll show with Wheeler, but essentially what happens is they're on the sub-Tor level, but they're still individual N tors, right? When they rotate like that, this one links with that one, this one links with that one, and links with another one there. That gravitational wave creates a new gravitational azimuth through the center of the plane. That pinches these in, increasing the gravitational azimuth. That pinches it in. So it's a self-feeding loop. And they self-organize to the point at which their non-radiating boundaries repel each other. And then they form the tor above. And it's literally like that. You cannot even imagine how fast that will occur. And when they come together, they have to...
Is that why they converge?
They're self-converging, self-aligning, self-organizing. And it's all through gravitational waves. And you have to let me get Wheeler say his piece, because everything you need to know is in what Wheeler says. So we're going to find out how to play this. If you've got any other questions, I will see what...
I also want to ask too.
Yeah. Go on.
Quick clarity. So I was thinking maybe, can you to the, like, let's call it teleportation aspect again one more time, and then show the video.
Okay.
And then after that, like you to, plug whatever you want to plug.
Okay, but I don't have much to plug. I don't have much to plug. Okay, so the teleportation, okay, so when you are in these structures, I believe that because the epsilon zero has changed, you're in your own space-time bubble, you will not really perceive time. And because you are in a fractal torus, and because your brain works on the toroidal moment, conscious brains need the toroidal moment for cognitive function, right? This is how people can do telekinesis, and how Ninel Kalagina could stop a person's heart and move things around. She had the ability and the understanding to control these things. You can go and look up Ninel Kalagina. Anyway, so if you are in there, your time will basically stop. Now, if you can move at 1/10 of the speed of light, you have no inertia and you have no mass. You can accelerate fast and you can slow down fast. Okay. Now what you do is you have no perception of time. In one blink of an eye, you're on another point in the planet and you're suddenly stopped. And that's it. To you, you have teleported, right? Because in the blink of an eye, you're in a completely different location. So perceptually, you have teleported. Okay, and I've been joking to my wife's Vietnamese, and I've been joking to her, like, at some point, honey, I'm going to be able to go to Vietnam, and we're going to be able to visit in our lunch break and come back through the planet, not around the planet, through the planet.
The amount of energy is minimal, right? That we got to pull this off. That because of these electromagnetic effects that are happening, where it's just amplifying itself, we don't even need a large amount of energy to pull this off.
So imagine one electron. Imagine one electron. That's how much energy you have to move that one electron, right? Now, you have to move that electron from here to here.
Nothing.
It's almost zero. And it's well described in Ken Shoulder's papers. Almost effortlessly. Now, the point is, why would you not want this technology to get out? Well, you imagine everyone has a craft that uses nearly no energy, and they could go to any point on Earth, and they don't have to go through baggage control, they don't have to show their passports, they don't have to do X, Y, and Z. How the hell could you completely control humanity? How could you? Well, you would have to convince them to have a chip in their body which would switch them off. And by the way, the same technology...
Yeah.
Anyway, I don't want to go into what else you can do with the technology. It's bad enough with this. God.
I was gonna say too. It's like I was thinking, we can make infinite energy, but now it's almost the opposite. We just don't need any energy.
You don't need it.
Having any amount of energy now becomes 10 times.
I've said, look, you've got a hydroelectric. I'll tell you how you can make an energy generator from this. You've got a hydroelectric dam. Excellent. We're already 99.9% of the way there. We use one of these structures, we capture 4 million tons of water, and we put it in your reservoir at the top. We let it run through your generator. Done. And there's many ways you can think about this. Like, you want a heat pump? We use single bath thermal extraction. You make an extremely cold area over here, and you make an extremely hot area over here by using the reverse, and you have a hot and a cold zone. Well, you can use a thermoelectric generator. You can change the epsilon zero for one side of a load of rocks on a pulley system running around two cogs tied to a dynamo, and literally this side's lighter, and all the time it's within the beam of that, and it goes around in a loop. And when it goes over the top, it's heavier, right? There's so many ways you can make an electrical generator, but the reality is you can convert matter to energy. Now, if you take 2 deuterons and you fuse them, that's 25 roughly million electron volts, right? If you take carbon and oxygen, you get CO2, that's 5 electron volts. So you can see why 25 is bigger than 5, right? Even if you take 5 and you divide it by 4 nucleons, that's a lot bigger than 5, right? It's 25 million, right? But if you take a nucleon in a baryon, like a proton or a neutron, and you turn that into pure energy by unraveling all of that electromagnetic energy that's trapped in that non-radiating structure, that anapole that is the baryon, right? If you rip that apart, it's over 900 million electron volts. There is nothing beyond this. There is nothing beyond this. It's 133 times more energy than you get from fusion. Do you understand the magnitude of this? And yes,
basically infinite energy at that. Yeah.
As Salvatore Paya says, I'm paraphrasing, but in his patent, like we can destroy asteroids, but we can also generate. We can take 4 units about the size of a domestic fridge. We can put them around the central plane of the Earth, and using the power to run a domestic kettle for a week, we can create a singularity at the center of the Earth, and the entire Earth will disappear. That's basically what it says in the Salvatore Paya patents. And on the next line, it says, using this
that's the same conclusion I came to.
Using this application of this principle, we can also do fusion energy. Now you can do matter to energy direct conversion. Now, this is where you have to understand, this is the great power. Anyone that has a face has the answer. This is the structure, right? So we are built in the technology that runs the entire universe, and can build it and completely unbuild it, right? Depending on whether it's going one way or the other. And the weird thing is I used to mock Star Trek for always having these aliens with just a load of prosthetic on their face. We are the answer to the program. It's in our face. So I've got to get this Wheeler thing, because it's the most succinct way.
Yeah, pull up Wheeler. And then,
that
was amazing. Thank you, Bob, for that explanation. I appreciate that.
This is the new dawn of an old age. And why is that not playing? Is it going to play there? Go on, play for me. Maybe I've just got no resources. I'm going to close that down and restart it again. Okay. I'll close down.
No problem.
This as well. No, I won't close Zoom. That would be a problem.
While you're pulling that up, I thank you for being on Hard Truths for 2 here today and going through all this evidence. I think that this is the perfect example of hard truths. This is information that a lot of people have a hard time understanding and accepting. Just went through the implications just a second ago. I mean, we are talking about new sources for being able to need very little power to move things and essentially port them throughout the planet, or technology that could actually create doomsday weapons and this whole planet. No.
You can destroy suns. You can destroy suns.
Yeah, we can destroy maybe. I mean, I don't even want to necessarily go into all the implications there, because it starts to freak me out a little, but it's very scary. Very big. It means that we have to be very responsible, I think, with this technology.
I'm not going to be religious here, but I'm going to say, Jesus said, "The meek shall inherit the earth." But the word meek is a mistranslation from praus, from the original Greek. And it actually means those that know that they have great power, but choose not to use it, will inherit the earth. There's one significant problem with this technology. If it's used in a war, I believe it will destabilize the magnetic field that locks the crust to the Earth's mantle. And we will have a cataclysmic event. It cannot be used in war. You cannot use this in anger. I'm not talking about destroying the planet. I'm talking about wiping everything off the face of the Earth. Literally wiping it, like with a cloth.
I understand.
Yeah.
It makes me even not trying to reveal this technology. You can understand this is most likely why it's being held back. The reason disinformation is that the same people with the same conclusion that you and I have come But the reality is, I think that we hide this forever. Humanity deserves it. As you pointed out, it can change the world. It can change the circumstances of millions, if not billions, as I've brought up, of people that have nothing on this planet. But we have to use it responsibly, right?
Absolutely, Ashton. You are bang on. Absolutely bang on. And the thing is, we used this on Earth before. It's in all of the ancient symbology. Every aspect of this is precisely in the ancient symbology. And any species at any point in the universe can easily learn how to do this from just observing nature. Like I said, I did no maths and no preconceptions. I literally looked at what was under a microscope, what's going on, and I started drawing pictures until, oh my God, this is how it works. And it's so simple. Right, I'm going to see if Wheeler will work now. Yes, okay, he's going to work. So let's see. Right, I'm going to move you down here. Yeah, I think so. What up? And he speaks really slowly, but that's good because I'm going to stop him, and I'm just going to fill in the that slideshow. And this is the guy that invented black holes, right? So presenter view.
Ken Wheeler.
Yeah.
Right?
Yeah. Okay, is it going to do it for me or what?
Radiation, a pencil of radiation.
I need to share my screen, don't I?
I hear it, yeah.
Yeah, I need to share my, because they're seeing it, but you're not seeing it. So I want it on your recording.
That's fine. Is it there's?
No, I want it on your recording.
In here as well.
Where are we going? Where have you gone now? Oh no. I've got about 1 million windows open here. Right, share screen. I want desktop 2. Share. Okay, right. Okay, all right. All right. Okay, so you can see it here, and I'm going to go onto Wheeler here. Wheeler Dealer. Take it away. Right, go on, do it for me.
Radiation, a pencil of radiation carries energy with it, and energy has mass, and therefore a pencil of radiation must exert some attraction on things beside it.
Okay. Pencil of radiation, so let's say a light beam. It's got energy. E equals mc squared. It therefore must have mass. Therefore, it exerts some attraction around it.
What about getting a pencil of radiation curved into a circle so the light goes round and round? Then the attraction it exerts is concentrated as if at the center. So what is it that bends this circle, this pencil of radiation into the circle? It's the gravitational attraction of the pencil of radiation itself.
So this structure here, which looks very much like the structures I derived, this is from his 1954's Guillon's paper. This has a gravitational azimuth going through the center. That is a stable structure called Guillon, and he predicted that things in the universe were made like this. Okay? So everywhere around this pencil of radiation that's going around, you have an attraction. But this stable structure is held together by the gravitational azimuth. That means there is a gravitational vector going through the center. As I said before, there will be a gravitational beam going through the center of this. Right, let him carry on.
That was the idea of the Jihan. Actually, if you think of different possibilities for the size of that Jihan, bigger or smaller, you find that if it's very big, the energy is low. To push the radiation together requires energy. And you climb a hill like the hill of a volcano until you've come to a maximum energy.
So, to do this ordinarily, you have to put energy in to push it together, and it takes more and more energy to push it together. Okay, wait.
And then, if the pencil of radiation becomes any smaller in size, the energy starts to go down, and the thing collapses. So a Jihan is really an unstable entity. It either blows up into a cloud of radiation traveling collapses into a totally collapsed object, something that we today would call a black hole.
Okay. So if you can push it together enough, the thing would collapse into a black hole. But wait, there's more.
But that stability analysis I didn't have in mind when I first published this work. Only later did I see that that's the feature that's dominant. But nowadays, I'm attracted with the idea that this pencil of radiation going around in a circle does not have to be light. It could be gravitational waves.
Right, so we already know we've got a gravitational beam coming through here, through our structure, right? Wait.
And you can have gravitational waves imploding to make a black hole.
There you go. Everything you need to know is in that little clip by the guy that came up with the term black hole. It's
that's amazing.
For me, it's a bit of a spiritual moment to be able to decode that. And this is a guy at the end of his life when people get honest. Sorry, go on.
I was just going to say, I think that for me, I was going to say just very brief that, uncovering the science behind this has actually led to me a better spiritual understanding for me as well. This is also deep, and I think from this perspective, it's just completely unknown. So the last few months of learning from you and other engineers, physicists, has given me a whole new understanding of our reality to be. So thanks for sharing that John Wheeler video. It's awesome.
Yeah, so it's freely downloadable from remoteview.icu. It is my practical applications for the fractal toroidal moment. What I mean is each substructure, which can go down to toroids that are twice the diameter of the Planck's distance, and each level can have 2 or up to 48, but maybe a little bit more subtors. You can imagine there is almost unfathomable numbers of ways this can be organized, but the things self-assemble so darn quick. And what he's saying there is that what I started out with is these tors, when they arrange themselves so the gravitational waves are pulled into the next one and pulled in, they pinch in, they make the new gravitational azimuth and pinch in until it forms a stable structure. And at that point, it's not in our space-time. It either collapses, which he says, it can go into a black hole, and I've described how when those things occur, you're not necessarily expecting thermal energy out. You're going to get other forms of field energy out. Or you could have a stable structure that is self-similar, like the ones that were brought in the first place, and can be manipulated in all of those magical ways you saw them being manipulated when they were brought into the side of the plane. I would like to think it's the latter. That's what I would like to think.
Awesome. Well, thanks, Bob. I appreciate you having being on here for Hard Truths number 2. You were a great guest here today. You went through some awesome something. You blew a lot of people's minds. So I would just close it out by asking you, go ahead and plug, whatever you want to hear at this point. Shout out anyone you shout out. This is your opportunity. Go ahead. Thanks a lot, Bob.
Okay, well, I want to thank all of the people that supported the Martin Fleischmann Memorial Project at quantumheat.org over the years. You can find us on the Martin Fleischmann Memorial Project on X, on Facebook, on YouTube, and you can also see my own personal writings on remoteview.icu, and that is the tagline on that is "Back to the Future Through Insight and Critical Fiction." And I would also particularly like to thank the late Neil Crichton Gold, who came up with who's confident enough in an experiment that I suggested. And produced some incredible experiments. And also Henk Uren in recent years, my wonderful colleague Alan Goldwater in California, without which his SEM I would not have been able to understand many researchers that have shared their information with us over the year, and David Boutlier, who produced some of the most fantastic coherent matter traveling waves and allowed us to decode this thing that I was talking about, how they project something in front of them that is able to affect light objects. I'd also like to thank the sadly departed earlier this year Takaaki Matsumoto, We have a reprint of this book, Steps to the Discovery of Electronuclear Collapse. I recommend everyone get a copy. We make 2 cents on this in royalties, $2 cents. So if you want to donate to the project, pretty much every video it has ways in which you can donate to the project underneath it. Everyone that's worked with the project has done it on a essentially on their own resources basis. They've often given up jobs, or they've had no other income at other times and stuff. But for me, this is the great. I call it, since the early 2017, the God's toolbox. I say that with a little g, because there are people out there that have stolen the big G's, God's glory, and they are taking it from themselves and they are using it. And the other ways that this can be used is just everything you can possibly think of that you can do. I can't watch a superhero movie because everything is possible. Freeze rays, instantaneous annihilation, cloning, teleportation, every single thing is possible. And it's you have to completely change your framework of reality when you get this, and also that it is based on the sacred geometry. Every single classical building from the ancient world through to the Greek architecture and the Roman architecture and every derivative from that, and obviously the Christian church is just a manifestation of this. The Great Pyramid of Egypt, all of these things, they are based on this technology. And if you want to understand a small fragment of that, go to the Martin Fleischmann Memorial Project's YouTube channel and follow every presentation that starts with the phrase O-Day. You can search O-Day. It's spanning 6 years. You can follow my personal journey, unredacted, even the stuff that I get wrong, the experiments, the live SEM sessions, everything that explored this thing. And I want to thank the community that have been with me whilst I was in stealth mode, essentially these past 6 years, trying to get the stuff out of the door so it cannot be unsaid. If anyone else has a terabyte out there and can download 4K downloader, I'd be very happy for you to clone the channel. And if you want to use any single piece of material that is published by the MFMP in video form, in image form, or in on the any way, please do so. Obviously, crediting the project and backlinking. But we are at the dawn of new dawn of an old age, and it's great to be back. This is our species inheritance. We are built in the image of the technology that drives this, but we shouldn't let those that want to lord it over us and hold dominion over us to use this technology to control both our physical reality, our perceptions of what is possible, what is right and just, and what literally control our minds, which is something you can do with it as well. So on that level, I would say you do not need to fear nuclear weapons. You do not need to fear them at all. It's a fraud, because they can make them disappear from the sky. They can make them disappear from the sky. Your money is being taken out of your pockets for things that are not real things. And there needs to be some coming together of nations to recognize that this is a real possibility, the immense threat this could present on a completely disappearing of our planet state level, but also the fact that we are being lied to. We have an ability to convert matter directly into energy, to travel without all of those tedious time delays and nonsense. And this planet, with this technology, could support 10, 20, 100 times its current population without flooding another rainforest, chopping up a load of tens of thousands of eagles, all kinds of technologies which are really, really rather redundant when you understand what is possible with this. I want to thank Ashton for his incredible hard work on getting this information out. Please share this, Ashton's work, very, very widely, and learn. If you have any questions, come to remoteview.icu, ask them. I tried to do a regular blog post video session on a Sunday night if I can. This is in lieu of that, but hopefully you can come along and ask questions. Obviously, it's helpful if you've done the homework. Some people have watched every video we've ever put out over the last 11 years, and that takes 4 months. There's people that just do the O-Day, and I think you can probably do that with the reference article. And everything that I have published, it's links back to mainstream scientific journals, and we have shown experiments that you can conduct, even as a 3-year-old, in 7 minutes that shows this basic principle with a $35 budget. Okay, it's literally Galileo asking the people calling him a heretic to look through the telescope and see the planets as they are actually moving. We are at that point of absurdity in this revelation. So thank you very much, Ashton. Thank you for giving me the forum to blather on there.
Yeah, and so I just want to say on behalf of MH370X organization, we're up to solve the videos, looking to advance technology. We want to give you an honorary membership into our organization. We want to let you know, welcome to MH70X, sir.
I'm honored.
So
I'm honored.
For today's podcast on hard truths, and let's be in touch. I'd like to talk to you again in the future, learn the science, keep up the good works, and thank you again.
Thank you very, very much.
Stopped.
And all those on YouTube,
Yeah,
thank you very much. I'll see you soon.
Appreciate it. And I think that if you want to just put your in the chat.